wave-particle duality. Have you ever considered that the tiny pieces that make up everything, light, electrons, even you, can behave like both waves and particles simply by changing how we look at them? It's a surprising thought. One moment, these bits act like solid marbles. Next, they spread out like ripples on a pond. How can something be both? This mystery sits at the heart of quantum physics, and it invites us to rethink what we know about reality. Have you ever felt two things at once, like joy mixed with sadness or courage tinged with fear? That strange blend is familiar in our everyday lives. We accept it without a second thought. But when it comes to the very building blocks of the universe, that dual nature becomes a cosmic puzzle. If you've ever experienced a moment where you held two feelings at the same time, share it in the comments below and let us know where you're watching from. It helps us all feel connected in this shared wonder. Imagine you're at the edge of a calm lake. You skip a stone, and ripples fan out in neat circles. You see wave patterns crossing, building, and fading. Now imagine you toss a single pebble, without ripples, just a solid splash. In our everyday world, waves and particles feel completely separate. But in the quantum realm, tiny bits, photons of light or electrons, can do both from one moment to the next, depending on how we observe them. Let's think about an exam. Picture two students sitting side by side. One studies by reading silently, the other by listening to a lecture. Their methods are different, yet both reach the same result. Similarly, a quantum bit travels like a wave when left alone, spreading out, exploring every path. But the instant we measure it, it snaps down into a single point, choosing one path or one answer, like the silent reader or the listener, each finding their own way to understanding. This phenomenon was first revealed in a simple but elegant experiment called the double-slit test. You shine light through two narrow openings onto a screen. If light were only particles, you'd see two bright spots. But what appears is a pattern of alternating light and dark bands, an interference pattern. It looks just like waves overlapping. Yet when you send individual photons, one at a time, they still build that same pattern over time. Each photon seems to go through both slits at once, like a wave, and yet it lands as a single dot, like a particle. That experiment teaches us that behavior depends on observation. If you place a detector at the slits to see which one a photon goes through, the interference vanishes. Suddenly, photons act like particles again, making just two spots. Your act of looking, your choice to gather information, changes the outcome. It's as if the universe adjusts itself in response to your questions. In everyday conversation, we ask questions to shape answers. We might ask a friend how they feel, and the way we ask, gently, directly, indirectly, guides their response. In quantum physics, the question is the measurement itself, and the answer is the particle's behavior. The mere act of asking, which path, forces the photon to wear its particle hat. When we stay silent, it puts on its wave cloak. This wave-particle duality stretches beyond physics. In belief, it reminds us that truth can hold multiple forms. A story can be both a fact and a metaphor. A dream can be a simple movie of the mind or a hidden gateway to deeper insight. Our own identities can feel solid in one moment and fluid in the next, perhaps confident today, uncertain tomorrow. Just like the photon, we shift shape when looked at from different angles. Language shows us similar duality. Words can carry literal meaning and hidden nuance. We say, "I'm fine," and sometimes we mean it, and other times we're asking not to probe deeper. A single sentence can ripple with many layers, like overlapping waves. But when we focus on just one word, we lose the subtle harmony that lives beneath. In mental health, wave-particle duality reminds us to balance observation with compassion. We might track our moods in neat data points, happy, sad, anxious, but inside, emotions ebb and flow like waves, overlapping and merging. If we measure too harshly, labeling every spike and dip, we can lose the continuous story of healing. And if we ignore measurement entirely, we risk missing patterns that could guide us to care. Even in technology, AI mirrors this mystery. Neural networks process data like waves of signals, but at decision time they produce single, clear outputs. They learn patterns, spread across vast possibilities, and then collapse into one classification or one answer. We train them, adjust their parameters, and watch them transform fluid learning into concrete results. Yet, if we probe them too closely, they can become brittle, losing the subtle patterns they once rode. So how can we live with this paradox? Perhaps by embracing both sides. We can learn to treasure our solid moments, our achievements, our clear choices, while also honoring the times when life ripples unpredictably around us. We can ask questions without fearing the answer will change everything. We can notice that looking closely at one detail might alter the whole picture and find peace in that dynamic dance. Next time you feel torn between certainty and uncertainty, think of the photon. Let its story teach you that reality is more nuanced than it seems. You need not choose only one form, wave or particle, certainty or mystery. You can hold both. You can float in the ripples of possibility and still find firm ground when you need it. If this paradox sparks your imagination, I invite you to like this video and share your own dual experiences below. Maybe you've felt two emotions at once, or made a choice that revealed unseen paths. Let us know where you're watching from and how wave-particle duality echoes in your life. And if you haven't already, subscribe for more gentle journeys through the strangest corners of science, designed to soothe your mind as you drift off to sleep. Thank you for joining me in this quiet exploration. Remember, sometimes seeing is not believing. Sometimes believing is seeing. And in that space between, we find the true mystery of our world, Schrödinger's cat. Have you ever felt stuck between two choices, unable to know what will happen until you finally decide, like waiting for exam results or opening a message that could change your day? You're frozen in that space between knowing and not knowing. Now imagine if a living creature, say a cat, were also suspended in such uncertainty. Not just waiting, but both alive and dead at the same time. That's the strange and haunting idea behind one of quantum physics' most famous thought experiments. And it might sound like fiction, but it's rooted in real science. Before we go deeper, tell me this. Have you ever had a moment in your life where two outcomes felt equally real until you found out the truth? Maybe it was a job interview, a confession, or a turn in a relationship. That space of not knowing can feel like floating in midair. If you've ever felt that way, let us know in the comments and share where you're watching from. You're not alone. That feeling is at the heart of this story. Let's imagine a cat placed inside a sealed box. You can't see in, and you can't hear anything. Inside the box is a small radioactive atom that might decay or might not. If it decays, it triggers a device that breaks a vial of poison and the cat dies. If it doesn't decay, the cat lives. The twist? In the world of quantum physics, until you open the box and look, the atom is both decayed and not decayed. It exists in a mix of both possibilities. And because the cat's life depends on that atom, the cat too is considered both alive and dead at the same time. This idea feels impossible. In our everyday world, things are either one way or another. The light is on or off. The door is open or shut. Your friend replied or didn't. But in the strange realm of quantum physics, something can exist in a superposition, a state where all possible outcomes are layered together like a shuffled deck. They only become one clear result when someone observes them. It's like having a wrapped gift in your hands. Is it what you hoped for, or something entirely different? Until you tear off the paper, it is both. The joy and the disappointment live together, quietly waiting. And only when you peek inside does one version become real. This thought experiment, proposed by Austrian physicist Erwin Schrödinger in 1935, wasn't meant to be taken literally. He didn't believe there were real cats living in this limbo. Instead, he wanted to show how odd and unsettling quantum rules become when applied to larger objects, like a living creature. He was challenging the idea that the act of measurement could change reality. Still, the image of the cat caught people's imagination, because deep down, we understand what it means to be caught between outcomes. In relationships, we wonder, does this person love me or not? In exams, did I pass or fail? In uncertain moments, both answers feel real, hovering in our minds, until something tips the scale. This paradox also asks a deeper question. Does something exist a certain way only when we observe it? If we never look, what is the cat's true state? What is reality if it depends on someone watching? In this way, the story connects to how we form beliefs. Sometimes we believe something simply because we haven't questioned it. Other times, the very act of looking closely can change what we believe. A quiet doubt, once examined, may become clarity or confusion. Like the cat, our thoughts are not always fixed. They can live in mixed states too, holding both fear and hope, love and uncertainty. Think of friendships. Maybe you've had one where trust was shaky. You weren't sure where you stood, until a conversation happened, like opening the box, and the truth, good or bad, was finally clear. Before that moment, you were like Schrödinger's cat, suspended in possibility. Even in language, we live with this uncertainty. A message without tone can be read two ways. Sure could mean agreement or quiet annoyance. A sentence, like a closed box, hides different meanings inside until you interpret it. In this way, even words live in superposition, shaped by how and when we read them. Mental health, too, reflects this paradox. People may appear fine on the outside but hold many emotions inside. Until someone gently opens that box, through conversation, kindness, or listening, we can't know what state lies within. Just as in quantum physics, observation changes things. Awareness makes a difference. It brings hidden truths into the light. And in AI and technology, the idea of superposition finds echoes in probability. Algorithms often hold many possible predictions, at once calculating which is most likely, then choosing. Just like opening the box, the final decision depends on how and when we measure. We train machines to narrow down possibilities, but deep inside, they are balancing between outcomes before they choose. So what can we learn from this strange cat in the box? Maybe that uncertainty is not something to fear. It's part of how the world works, both in science and in life. The unknown can hold many truths at once. Sometimes we must sit with that discomfort. Sometimes we must trust that clarity will come when it's time to look. And perhaps most importantly, this paradox reminds us to be kind. You never know what state someone else might be in until you gently open the box of conversation. Your awareness, your choice to check in, could shift their reality from hidden pain to shared connection. If this story touched something in you, please like this video and let us know your thoughts. Have you ever felt like Schrödinger's cat, living with two possible truths, waiting for clarity? Share your story in the comments and tell us where you're watching from. And if you'd like more gentle explorations of life's strange and beautiful mysteries, consider subscribing. Together we'll continue walking through these quiet puzzles that help us see the world and ourselves a little more clearly. Thank you for being here. And remember, not everything has to be answered right away. Some boxes take time to open, some truths take time to see. And in the waiting, there's a quiet kind of wonder. Quantum tunneling. Have you ever found yourself stuck in a situation that felt impossible to get through? Like being trapped behind a wall of problems, no door in sight. And then, somehow, without knowing how, you're on the other side. Not because the wall disappeared, but because you moved through it in a way no one expected. What if I told you that deep in the heart of reality itself, there are particles doing just that, passing through barriers they shouldn't be able to pass, like magic but real? This is the strange and beautiful mystery of quantum tunneling. Before we explore this idea together, I'd love to know, have you ever had a moment in life where something just slipped through? A miracle you didn't expect? A moment of ease in a time of struggle? Share it in the comments if you feel comfortable and let us know where you're listening from. These quiet experiences often reveal how close we are to mystery every day. Now, in our everyday world, when something hits a wall, it bounces back. If you roll a ball at a fence, it doesn't pass through. If you run at a closed door, you stop. That's what we expect. Solid things can't move through solid barriers. But in the world of quantum physics, the rules start to bend, and sometimes they break in surprising ways. Imagine a tiny particle, so small you can't see it, approaching a barrier it doesn't have the energy to climb. By classical logic, it should stop. It should reflect back. But in the quantum world, particles aren't just tiny dots. They also act like waves, and waves can spread out. They have a little bit of themselves in many places at once. Because of this, part of that wave can leak through the barrier. And sometimes the particle appears on the other side, without ever climbing over. It's like the universe allows it to wink through a wall. It sounds impossible, like walking through a locked door without opening it. But this happens, and not just in theory. Quantum tunneling is real. It's not a glitch or a fantasy. It plays a role in how the sun shines. Deep in the sun's core, particles need to get close enough to fuse together, but they don't have enough energy to overcome their natural repulsion. Still, tunneling lets them slip through that barrier and create the light and warmth we depend on. This quiet miracle also shows up in technology, in tiny devices like tunnel diodes and scanning electron microscopes. Even the process of radioactive decay involves particles escaping through barriers they shouldn't cross. The universe, it seems, has a hidden pathway for the impossible, a secret doorway through the wall. Let's slow down for a moment. What does this mean, not just in physics, but in life? Sometimes we hit barriers that feel unbreakable. A failed exam, a lost job, a broken friendship, a deep sadness. These feel like walls. They tell us we can't go forward. But sometimes, without warning, something shifts. A tiny opening appears, not a door we open with force, but a quiet permission, a passage we never expected. In that sense, quantum tunneling speaks to something very human. It tells us that the boundaries we see might not be final, that even when everything says you can't, there may still be a way through, not by pushing harder, but by existing differently, by trusting that not all movement is loud. Some changes happen softly, like light through a crack. It also reminds us how complex we are. Like those particles, our thoughts and feelings don't always stay in one place. They drift, they spread, they touch things we can't always see. Maybe we think we've moved on from something, but echoes of it remain. Or maybe a part of us is still trying to cross an old barrier, hoping for closure. Our emotions, like quantum waves, don't stop at hard edges. Even language can carry this mystery. Sometimes a word reaches someone's heart, not because it breaks down their defenses, but because it slips gently through. Think of the times someone said something simple, but it stayed with you. A quiet, "I'm here," or "you're doing okay." Words that tunneled past fear, past doubt, and touched something real. Mental health, too, has its own version of tunneling. Healing doesn't always happen through big breakthroughs. Sometimes it comes quietly, through small changes, a moment of calm after weeks of noise, a kind thought after days of criticism, a breath, unnoticed, that carries you to the other side of a hard moment. Like a particle crossing a wall, not with force, but with presence. Even in AI, the idea has a parallel. Some algorithms find unexpected pathways through problems by looking where humans wouldn't. They don't climb over the challenge. They sidestep it in ways that surprise us. Just like particles tunneling, they remind us that creativity isn't always direct. Sometimes the best answers come sideways. So what does quantum tunneling truly teach us? That the impossible might not be so impossible after all. Those barriers might be softer than they seem. That with enough patience, enough openness, even the hardest wall might let something pass through. Maybe there's a part of your life where you feel blocked right now, a part that feels like it can't move forward. If so, hold this thought, gently. Sometimes movement doesn't come with noise. Sometimes the shift is quiet, invisible. And yet, suddenly, you're on the other side. If this reflection meant something to you, I invite you to like this video and leave a comment. Tell us, have you ever experienced a quiet breakthrough? Something that slipped past the wall when you least expected it? And if you enjoy these peaceful, thoughtful stories, consider subscribing. Together, we'll keep exploring these small mysteries that live all around us and within us. Thank you for sharing this space with me. And remember, just because a wall looks solid doesn't mean it's final. Sometimes you are already halfway through. Sometimes the universe is gently carrying you past it, even if you can't yet see how. Delayed choice. Have you ever made a decision only to look back and feel like your choice somehow reached into the past and changed how you remembered things? Like choosing a path in life, and suddenly your past feels different, even though nothing has actually changed? What if I told you that, deep in the world of quantum physics, there's an experiment that suggests something just like that, where a choice you make now seems to affect something that happened earlier, almost as if time itself was folding back on itself. Before we journey further, take a moment to reflect. Have you ever looked back at a moment in your past and felt like it made more sense only after something happened later? A new friendship? A lost opportunity? Or a sudden realization that gave old memories new meaning? If so, you're not alone. Share your story in the comments if you'd like, and let us know where you're listening from. These moments remind us how the line between past and present is often softer than we think. Now, to understand this mysterious idea, let's picture a classic scene in physics, a tiny particle, like a photon, being fired toward a screen with two slits. This is called the double-slit experiment. If you don't measure which slit the particle goes through, it acts like a wave and creates an interference pattern, like ripples from two stones thrown in a pond. But if you do check, the wave-like behavior disappears. The particle acts like a little dot and chooses just one path. It's as if the particle knows whether it's being watched and changes its behavior. But here's where it gets even stranger. In the delayed choice version of this experiment, something odd happens. You let the particle go through the slits without checking which path it took. Then, after it has already passed through, you decide whether or not to measure it. And somehow, your later choice seems to determine what the particle did earlier. If you choose not to measure, the interference pattern appears. If you do measure, it vanishes. It's as if your decision in the present reached back in time and changed the particle's history. This doesn't mean you're literally changing the past, but it suggests something deeply mysterious. In the quantum world, the past may not be fully written until it's observed. The story isn't finished until you read the last page, and sometimes that last page changes the whole book. In daily life, this might feel far away, but let's bring it closer with a simple example. Imagine you're in a relationship, and years later, after it ends, you find a letter you never read. That letter changes how you remember everything. Suddenly, arguments seem softer, moments make more sense. You feel sadness, clarity, maybe even peace. The events didn't change, but your understanding of them did. In a way, your new perspective reached back and rewrote how it all feels. That's what the delayed choice experiment whispers to us, not about rewriting facts, but about how observation itself shapes what is real. This idea can also speak to our mental health. Sometimes we carry pain from the past, memories that feel heavy, frozen. But later in life, with new tools or deeper understanding, we revisit those moments, and something changes. Not the event itself, but the weight of it. Healing doesn't erase the past, but it changes the way we hold it. Just like the particle, the moment shifts because we're looking at it differently now. In language, too, we find echoes of this. A phrase like, "I didn't understand then, but I do now," holds more than reflection. It holds transformation. Our words, our memories, our meanings, they evolve over time. And when we speak them out loud, it's like measuring our own history, not to trap it, but to soften it, to understand it again with gentler eyes. Even in AI, the concept has meaning. Algorithms sometimes refine their earlier steps based on later results. They learn backward, like you typing a sentence and your software suggesting a better version, not just of the ending, but of the beginning. 2. This loop between what was and what is mirrors something deep, the future influencing the past in quiet ways. So what does delayed choice really teach us? Maybe it tells us that time isn't as fixed as we believe, that memory isn't just a record, but a living thing. That reflection can change not only how we feel, but how we understand what was. It reminds us to stay open, to let go of the need to have all the answers now. Because sometimes, only later will we see the full picture. And when we do, even the past might feel different. If you're someone who carries memories that don't make sense yet, this idea offers a gentle truth. You don't have to force clarity. Understanding may come when you're ready, and when it does, it might feel like time itself is healing, slowly, softly. If this thought helped you breathe a little easier tonight, consider liking this video. It helps more people find these calming reflections. And if you feel moved, leave a comment. Have you ever had a moment where something in the present changed how you saw your past? Or helped you forgive it? We'd love to hear. And if you'd like more of these thoughtful journeys, mysteries that quiet the mind and open the heart, subscribe. There's more waiting for you. Thank you for spending this time here. In this soft space between science and story, between what was and what could be. And remember, sometimes the story isn't over until we look again. Sometimes the past is still unfolding, quietly in the light of your gaze. Spooky action. Have you ever thought about someone deeply and just then they call you? Or you send a message and they say, "I was just about to text you." We often smile at this, thinking it's a coincidence. But what if, on a much deeper level, something like this really happens in nature, where two things, no matter how far apart, seem to stay connected? Instantly, silently, without a message traveling between them. That's what scientists once called spooky action at a distance. And it's one of the most mysterious and beautiful puzzles in quantum physics. As you settle in, wherever you are, your room, your car, maybe a quiet park, feel free to share where you're listening from. These kinds of thoughts, gentle and strange, have a way of bringing people together. We may be far in miles, but close in wonder. Now let's take a deep breath and imagine two particles, let's say two tiny photons, twins of light. They are born together in a special way, and then move apart. One might stay near us, and the other might drift far, far away. It could be next door, or across the galaxy. What's fascinating is that no matter how far they go, these two particles remain linked, like invisible dance partners, mirroring each other without delay. This is called quantum entanglement, a word that sounds big, but the idea is quietly simple. The particles are connected in such a deep way that if you do something to one, the other responds instantly. Not quickly, instantly, even if they are light years apart. It's like if you had two coins that were entangled. You flip one here on Earth and it lands heads, and no matter where the other coin is, in your friend's pocket on Mars, or floating, somewhere between the stars, it will land tails. Always. And this happens without any signal going between them. No light, no message, just instant response. That's what made even Einstein raise an eyebrow. He didn't like it. He called it spooky action at a distance, because to him it sounded too strange, too magical. And yet, again and again, experiments have shown it's real. Let's slow down here and connect this to everyday life. Imagine you have a twin brother. The two of you grow up close, deeply in sync. One day, you move far apart. He stays in your hometown. You move to another continent. But somehow, every time he feels joy, you smile. When he's sad, your heart feels heavy. You don't talk. You don't know why. But it happens. You're connected. That's how entangled particles behave. Not with emotions, but with properties, like spin or light direction. But the mystery feels just as human. We can even think about this in terms of relationships. Have you ever had someone in your life that you just knew, without words? You sense what they're thinking. You feel their presence even when they're away. You might not call it spooky, but it's a kind of unseen link. Maybe it's memory, or empathy, or something softer we don't yet understand. But we feel it, just like the particles respond. This quantum connection also touches on bigger themes, like time, space, and even free will. Because if two particles can stay linked across vast distances, it asks a deep question. Is the universe more connected than we think? Are we all part of one quiet whole, where distance is just an illusion? Some thinkers believe entanglement hints at something more than physics. They say it could show how everything, light, matter, thought, is part of a bigger pattern, a field we haven't yet mapped. Others say no, it's just math. But whatever the truth is, the feeling it brings is one of unity, of closeness across space, of invisible bonds that don't need wires or words. In AI, too, we see echoes of this. Machines trained together can sometimes show surprising patterns, almost like they're in sync. And in human minds, when we understand one another without explanation, we feel a sense of calm, like the universe is whispering, "You're not alone. You're part of something." Spooky action isn't about fear, it's about wonder. It tells us that some things in the universe don't follow the normal rules of time and space, and yet they still work in harmony. That brings a strange kind of peace, because it means connection is deeper than logic, deeper than wires. It lives in the silence between two things that once touched. And maybe that's true for people too. Maybe when we love someone deeply, when we share a story or a struggle or a dream, we get entangled in a small way. We stay linked, and even if we move apart, something invisible still moves between us. Like the particles, we respond to each other without needing to ask. So tonight, if you're thinking of someone far away, take a moment. Close your eyes. Maybe they feel it too. Maybe distance is just a number. Maybe we're all dancing in the same unseen light. If this thought brought you calm or wonder, consider liking this video. It helps others find their way here. And if you'd like, tell us, have you ever felt connected to someone far away, without a word? Leave a comment. Your story might be just what someone else needed to hear. And if you'd like to keep traveling through these soft mysteries, these sleeping thoughts from science and soul, feel free to subscribe. There's more to explore, more to remember, more to feel. Thank you for spending your time here, in the quiet, with the light, with the mystery, where connection doesn't always need a reason, it just is. Uncertainty principle. Have you ever tried to remember a dream right after waking up? For a few seconds it's there, bright, strange, detailed. But the moment you try to focus on one part, the rest begins to fade, like fog moving through your fingers. The more you chase it, the more it slips away. That's how the universe works too, at its smallest level. When you try to know one thing perfectly, you must give up knowing something else. This isn't a flaw in your tools or your memory. It's how the world is built. And that's what we call the uncertainty principle. As you take a deep breath and let yourself sink into this thought, feel free to share where you're listening from tonight. Maybe you're tucked into bed in a quiet room, or sitting by a window while the world winds down. Wherever you are, this space is here for you, a place to feel gently curious. Now, picture a tiny particle, like an electron. It's so small we can't even see it, not with any camera, not with any lens. But we can still ask questions about it. Where is it? How fast is it moving? What is it doing right now? These seem like normal questions, and in our everyday world, they're easy to answer. If your friend is riding a bike, you can look and say, "She's right there, going 15 miles an hour." No mystery, no blur, just facts. But in the world of tiny particles, it doesn't work like that. If you want to know exactly where the electron is, you can find that out. But then, the moment you do, its speed becomes fuzzy. If you try to measure its speed very carefully, then its position becomes unclear. You can never know both at once. Not fully, not exactly. It's not because your tools aren't good enough, It's because the universe itself is that way. The sharper your view of one detail, the blurrier your view of the other. Always. This idea was first described by a man named Werner Heisenberg, but you don't need to remember his name. What matters is the strange, quiet beauty of the truth he discovered. Let's imagine a real-life example. Think of a moment where you're watching someone you love, maybe a child running across a playground, or a friend dancing in a crowd. You're trying to see both where they are and how fast they're moving. But if they're moving too fast, it's hard to tell their exact spot. And if they stop for a moment, you can finally see where they are. But now they aren't moving. In some quiet way, that's a shadow of the same principle. Or think about emotions. Sometimes, when you're trying to explain how you feel, the more you focus on naming one feeling, the harder it becomes to explain the rest. If you say, "I'm angry," maybe that's true. But it might also be mixed with sadness or fear. The act of picking just one emotion hides the others. The moment you look too closely, the full picture fades. Not because you're wrong, but because life is layered. In that way, the uncertainty principle isn't just about physics. It's also about how we live, how we love, how we think. The idea that perfect clarity is not always possible, and that's okay. Some people find this idea uncomfortable. We want the world to be certain. We want to know where we stand, how fast we're moving, what will happen next. But the universe reminds us gently that some things are always in motion, always changing, always a little out of reach. And instead of fighting that, maybe we can learn to be soft with it. In AI and technology, there's a similar feeling. We train machines to learn. We give them data and patterns and instructions. But even then, there's a kind of uncertainty. We can guide their behavior, but we can't always predict every move. And in people too, especially in people, we often can't fully understand what someone is thinking or feeling, even when they try to tell us. That's not a failure. It's just part of being human. The uncertainty principle reminds us that some mysteries are built into reality. They aren't meant to be solved but accepted, like weather that shifts without warning, like memories that come back suddenly, like love that grows quietly over time without a clear start or end. It also teaches us something kind and gentle. You don't have to know everything. You can still move forward, even if the road isn't clear. You can still be present, even if you're unsure. And sometimes, letting go of the need to understand everything opens the door to peace. So the next time you feel overwhelmed by choices, or worried about making the perfect decision, remember the tiny particles. Remember how they move and shimmer and remain partly hidden, no matter how closely we look. And yet they still build everything. Trees, oceans, you, me, all made from particles that are never fully certain. But still, they create a beautiful, working world. If that thought brought you a moment of calm, or helped you see life a little differently, consider liking this video. It helps others find their way to these quiet places of thought. And if you've ever felt unsure about a choice, a relationship, a direction, tell us in the comments. Sometimes just saying, "I don't know," is the bravest and most honest thing we can do. And if you'd like to keep exploring these soft mysteries of the mind and the universe, feel free to subscribe. There's more to uncover, more to rest in, more to wonder about. Thank you for being here, for listening, for drifting with me through a thought that has no final answer, only quiet understanding. Because even in uncertainty, there can be great peace. Quantum Zeno. Have you ever watched the second hand of a clock so closely that it felt like time itself slowed down? That moment of intense focus, where each tick seems to stretch, can feel oddly familiar in our own lives. Now imagine that level of attention acting on tiny particles in the universe, so much so that your watchful eye actually stops them from changing. This is the heart of the quantum Zeno effect. The more you look, the less movement you see. It's as if the act of watching becomes a barrier to change. Think about a friend who is going through a tough time. You check in on them every hour, send messages, ask how they're doing. But sometimes this constant attention can feel suffocating. They stay stuck in that difficult moment because you won't let them move on. In the quantum world, a similar thing happens. When a particle is observed again and again, its state freezes and it refuses to evolve. The particle remains locked in place, caught under the gaze of the observer. Have you noticed this in your own life? Times when someone watches you too closely, maybe a parent, a teacher, or even yourself, can feel like a kind of pressure that holds you in place. You stall. You stop growing. You become hyper-aware of every small action, and suddenly nothing changes. If that rings true, share your experience and where you're listening from in the comments below. It helps us all feel less alone in this peculiar loop of observation and stasis. Let's journey back to the world of experiments. In a classic setup, scientists prepared unstable atoms that would normally decay over time. But when they measured these atoms repeatedly, checking whether they had decayed yet, the atoms stayed stable. Each observation reset the clock on decay, leaving them forever frozen. It's as if the atoms sensed the measurement and refused to change under the spotlight. Without constant measurement, they would have shifted and decayed naturally. Yet, the relentless gaze holds them in place, a silent jailer of change. This idea sounds unsettling. We tend to think that observation helps us understand and navigate the world. We believe that watching something closely leads to insight and progress. And yet, at a quantum scale, watching can become the chain that holds things still. It reminds us that sometimes stepping back and giving space is the best way to let life unfold. Imagine studying for an exam. You review each page, each formula, every definition. The more you pore over your notes without breaks, the more stressed your mind becomes. You memorize facts, but you're too tense to integrate them. You can't solve even the simplest problem because your brain feels stuck in that intense focus. Only when you step away, take a walk, or sleep on it, do you return refreshed and able to connect ideas. That momentary freedom from observation mirrors the quantum particle's release from its frozen state. In our relationships, the quantum Zeno effect often appears as over-monitoring. When we text a friend repeatedly, asking, "Are you okay?" or demand constant reassurance, we prevent natural change. We trap them in a loop of anxiety and response. Instead of giving them room to process, we force them to stay in the vulnerable state. True support sometimes means gentle trust rather than unending scrutiny. This paradox speaks to belief as well. In our minds, holding on to an idea too tightly can freeze our own growth. If we constantly check our beliefs against every new piece of evidence without allowing any breathing room, we become stuck in a rigid mental state. We fail to absorb fresh perspectives because our inner observer is too busy guarding the old position. Letting go of that intense self-observation can allow our beliefs to evolve naturally, just as releasing the quantum gaze allows the atom to decay. Even in language, a similar pattern emerges. When we over-edit our words, constantly revising each sentence, each phrase, we can block the flow of creativity. The text freezes, ideas vanish, and we stare at a blank page that never fills. Sometimes we need to write freely, then return to refine. The initial freedom mirrors the particle's unmeasured state, where possibilities flourish until we choose to observe and shape them. In mental health, the effect shows how self-surveillance can harm our well-being. Constantly measuring our feelings, rating our mood on apps, journaling every worry, can trap us in a cycle of anxiety. Instead of allowing emotions to rise and fall naturally, we fixate on each one. This fixation prevents the natural process of healing and acceptance. It is through periods of calm observation, coupled with moments of release, that we find balance. Artificial intelligence also hints at this principle. If we train a model with endless checks and rechecks, continuous retraining on the same data, it can become overfitted, stuck on specifics and unable to generalize. We must allow the algorithm space to learn, test, and evolve. Too much measurement in the training loop locks it into narrow patterns. A gentle, measured approach opens the door to broader insights and adaptability. So how do we live with the quantum Zeno effect as a quiet guide? Perhaps by remembering that observation carries power. Power to know, but also power to freeze. In moments of deep focus, ask yourself, am I helping the process, or am I trapping it? When you feel stuck, consider whether stepping back, taking a breath and trusting time might bring more progress than the next check-in. The next time you find yourself hovering over a task, a relationship, or a part of your own mind, pause. Acknowledge the urge to watch, to measure, to demand immediate change. Then, gently step away. Let the world and yourself breathe. Trust that some transformations happen best in the soft, unobserved moments. Even those tiny particles know it. If this idea resonates, please like this video and share your thoughts. Have you ever felt frozen by your own gaze or by someone else's? Let us know in the comments and tell us where you're joining from. Your voice helps build a gentle community of shared reflections. And if you'd like more of these soothing journeys into science and soul, subscribe to the channel. Hit the bell so you'll know when the next mindful mystery arrives. Thank you for staying with me in this calm exploration. Remember, sometimes the kindest act is to simply step back and let life flow. Even at the smallest scales, freedom comes when we relax our watchful eyes and trust that change will find its way through. Entanglement swap. Imagine you're on a call with your best friend. You're laughing, sharing old memories, finishing each other's sentences without trying. Now imagine, without warning, your friend disappears, and suddenly, someone else answers the call. But here's the strange part. The new person already knows what you were talking about. They've picked up right where your friend left off. You didn't notice the change, because something hidden passed between them. This might sound like a dream, or maybe a strange glitch. But in the world of quantum physics, it's not a dream. It's real. And it's called an entanglement swap. Has anything like that ever happened in your own life? A moment where someone new enters your world, and it felt like they had been part of your story all along? Like they knew the rhythm of your thoughts before you even said a word? If so, I'd love to hear about it. Let us know in the comments where you're watching from, and if you've ever experienced a connection that felt too deep or too perfect to explain. So, what is an entanglement swap, really? To understand it, we need to go gently into the quiet heart of the quantum world. At this tiny level, particles can become entangled. That means, no matter how far apart they stay linked. If one changes, the other changes too. It's like they share a hidden thread that no one can see. They don't use signals. They don't talk. They just know. Now imagine you have two pairs of these entangled particles. Let's call them A and B, and C and D. A is entangled with B. C is entangled with D. They are like two dancing pairs on opposite sides of a ballroom, moving in perfect step with their own partners. But something strange happens when you take one particle from each pair, say B and C, and bring them together in a special way. If you do it just right, the dance changes. Suddenly, A and D become entangled, even though they never touched, even though they were never close. The partners have swapped across space like a cosmic shuffle, and the connection is now between two strangers. This quiet trick doesn't break any rules, but it does break our sense of how connection works. We think that for something to bond, it must touch, it must share a history, a moment, a place. But here, the link forms without contact, without time. It's as if the universe whispered, "They belong together now," and made it so. You might wonder, how can something so small, something invisible, matter to us? But the echo of this idea is already in our lives. Think of people who enter our world unexpectedly and seem to change everything. A teacher who says the one sentence you need to hear. A stranger on a train who shares a story that stays with you for years. A friend of a friend who becomes your closest companion. These connections often feel random, but maybe in some quiet way. The swap was waiting to happen. Think about relationships. Have you ever held onto a connection too tightly, fearing that if it changed, it would vanish? Yet sometimes, letting go of one bond opens space for a new one to form. Different, but just as real. Life, like the quantum world, is full of these invisible threads. When one breaks, another forms. Not always through logic, not always through choice, sometimes simply through the mystery of timing. This paradox can even touch belief. Some people believe that everything is connected, that thoughts, emotions, or souls can influence each other across great distances. While science doesn't make such claims, the quantum world does show us that distance is not always a barrier, that deep, unseen ties can form and shift in ways we don't yet understand. It opens the door to wonder. Let's also think about memory. Imagine two old memories that were once separate, perhaps one from childhood, one from later life. Then, one day, you find a small link between them, a sound, a scent, a face. Suddenly, they feel connected. A bridge has formed in your mind. The swap has happened. The dance of memory changes, and what was once separate becomes part of one quiet story. Even technology mirrors this pattern. In artificial intelligence, ideas from quantum entanglement are helping shape future systems, where information might be shared without direct transfer, where links are not built through wires, but through structure, intention, and pattern. It reminds us that connection doesn't always require a straight line. Sometimes, it just needs the right conditions to unfold. In language, too, we find this. A word used in one context suddenly shows up in another, carrying a new meaning. Two ideas, once unrelated, merge. A metaphor from childhood becomes the perfect phrase in adulthood. The mind performs its own entanglement swap, bridging distance, building meaning. Even in mental health, we may see a quiet reflection of this idea. When we try to heal from something painful, we often find ourselves forming new connections in unexpected places. A song, a story, a stranger's words. Somehow, they help us process an old wound. The original pain remains, but its weight shifts. It's as if a new partner has stepped in, helping to carry what we once held alone. So what can we learn from this strange quantum dance? Maybe that life is not only about what we see. Those connections can form quietly, invisibly, and still change us. That distance doesn't always mean disconnection, and that sometimes a bond we didn't expect might become the one that matters most. The next time someone enters your life and feels instantly familiar, or when a sudden thought ties together two old memories, pause for a moment. You might just be witnessing your own kind of entanglement swap. A change that happened not through force or planning, but through the quiet design of possibility. If you enjoyed this reflection, please like this video. And if you've ever felt a connection that seemed to come from nowhere, or if a new bond helped you move forward from an old one, share it with us in the comments. Let us know where in the world you're watching from and help us build a community of thoughtful people, quietly connected across the map. And if this kind of calm exploration speaks to you, don't forget to subscribe. There's much more to come. Soft stories, gentle mysteries, and quiet truths hiding beneath the surface of things. Thank you for joining me tonight. And remember, not all dances begin when the music starts. Some begin long before, waiting patiently for the right moment to swap. Vacuum fluctuation. Have you ever felt completely empty, and yet something deep inside was still moving? Maybe after a long cry or sitting silently alone, it felt like there was nothing left. No thoughts, no energy, just stillness. But then, out of that quiet, something tiny flickered. A small idea, a tiny memory, a feeling you couldn't name. It didn't stay long, but it reminded you that even in your most silent moments, something was still alive inside you. Invisible, brief, but real. Have you felt that too? That sense of motion inside stillness? If so, share your story in the comments. Tell us where you're listening from and let others know They're not the only ones who've felt movement in their quiet places. In science, there's a strange and beautiful idea that speaks to this feeling. It's called vacuum fluctuation, and it tells us something surprising, that even the emptiest space isn't truly empty. Even in total stillness, something flickers. Let's take a moment to imagine the quietest place possible, a space with no people, no light, no air, no heat. Just nothing. Complete silence. That's what we call a vacuum, a space with no matter at all. Now, most of us would picture that as truly empty, like a clean blackboard with nothing drawn on it. But the universe has other plans. Because even there, inside that perfect nothing, tiny bursts of energy still appear and vanish. They come out of nowhere and disappear just as quickly. These are vacuum fluctuations, like tiny whispers inside silence. They're not loud, they're not big, they don't last long, but they matter. They remind us that nothing is never really nothing. Something is always moving, even when we can't see it. Think of it like this. Imagine sitting in a quiet room after everyone has left. You think you're alone, but if you close your eyes and listen carefully, you might hear something, the faint tick of a clock, a floorboard creaking, your own heartbeat. These tiny signs remind you that stillness is not the same as emptiness. Something is always stirring. In the same way, the vacuum of space, the parts of the universe with no stars, no planets, no light, are still filled with tiny flickers of energy. Scientists say they appear in pairs, a particle and its opposite. They show up, touch reality for a tiny moment, and then disappear. It's like the universe is breathing, in and out, even when it seems perfectly still. Now, why does this matter to us? Because it touches something deep and human. We often fear emptiness, a blank page, a quiet house, a lonely afternoon. We think of these as empty spaces, and sometimes they feel like they'll last forever. But vacuum fluctuation reminds us that even in the most silent moments, something is beginning. Quietly, gently, unseen. Have you ever stared at a blank page and suddenly felt an idea come from nowhere? Or walked alone and had a memory surface that made you smile or cry? These flickers may not last, but they're signs of life, of energy, of change. In relationships, too, there are times when things go quiet, when the talking stops, when the energy fades. It can feel like the connection is gone. But often, even in those silences, something is happening beneath the surface. A shift, a realization, a softening. The silence isn't always empty. It may just be holding space for the next spark. This idea also touches belief. Many people wonder how the universe began. Some believe it started from a big explosion. Others think it was spoken into being. But vacuum fluctuation offers another quiet possibility that something may arise, even from what seems like nothing. That silence is not the end. It may be the beginning. Language plays with this idea too. We pause when we speak. We use silence between words. And yet, those pauses aren't meaningless. They give shape to our thoughts. They let emotions land. A quiet pause in a conversation can speak louder than the words around it. The silence between notes is what gives music its shape. Maybe the emptiness in our lives is doing the same thing, framing the parts that matter. Even in mental health, this thought can bring comfort. When someone feels empty, emotionally flat or distant, it can be terrifying. It feels like nothing is left. Like joy, meaning, and connection have all vanished. But maybe, like in the vacuum of space, tiny sparks are still flickering in that stillness. Healing doesn't always shout. Sometimes it whispers. Tiny steps, small breaths, a shift that lasts just a second, and then another. These flickers may be hard to notice, but they're real. Artificial intelligence, in its own quiet way, reflects this too. Before an idea appears on a screen, before a sentence is written, there is silence. But inside that silence, code is running. Small actions are happening at high speed, choices being made, paths being taken. What looks like stillness is actually motion, just hidden from view. So, what can we learn from vacuum fluctuation? Maybe this: that emptiness is not the end of the story, that silence doesn't mean nothing is happening, that even when we feel most alone, most still, most uncertain, something may be stirring in the dark, a flicker, a whisper, a spark. Next time you're sitting in a quiet room and the world feels still, take a deep breath. Listen closely. You may not hear anything. You may not see anything. But that doesn't mean nothing is there. You might just be in the presence of your own kind of vacuum fluctuation, a quiet beginning. If you've ever found comfort in silence, or if a tiny spark helped you through a time of stillness, tell us about it in the comments. Let us know where you're watching from, and help us build a gentle, thoughtful community of listeners. If this quiet reflection helped you rest, or helped you think in a new way, please like this video. And if you'd like more stories like this, gentle, thoughtful, and easy to follow, please subscribe. There's so much more to explore together. Thank you for spending time here, for choosing to slow down, to listen to the silence, and maybe, just maybe, to feel the flicker that was always there, waiting. Superposition, collapse. Have you ever felt stuck between two choices, both possible, both real in your mind, and yet the moment you're forced to decide, everything changes? Maybe it was choosing a job, moving to a new place, or even telling someone how you really feel. In the days leading up to the moment, both futures felt alive. You could almost walk into either one. But the second you acted, only one path remained. The rest vanished, as if they had never been real at all. Have you had a moment like that, where your life felt like it could go in many directions, but everything changed once you made a choice? If so, tell us about it in the comments, and let us know where in the world you're watching from. We're all navigating different choices, but somehow the feeling is shared. In the world of quantum physics, there's a strange idea that mirrors this experience. It's called superposition collapse. It begins with something very small, a single particle, something too tiny to see. Scientists discovered that this particle doesn't live in just one state. Before we measure it, before we look at it, it lives in many states at once. It's not here or there. It's both, and neither. It exists in a cloud of possibility, a quiet dance of what could be. But the moment we observe it, the moment we look, it makes a choice. It collapses into a single state. One position, one speed, one reality. All the other possibilities fade, as if they were never there. It sounds impossible, but it's real. This quiet behavior of particles, appearing in many forms until they're watched, is part of what makes quantum physics so strange, and so deeply human. Because don't we do the same? Think of a student waiting for exam results. In those final moments before the paper is returned, their mind lives in a kind of superposition. Maybe they passed. Maybe they didn't. Maybe they did better than they thought. All these states exist at once in their imagination. But the second the grade is revealed, the wave of possibility collapses. The truth settles. The rest disappears. Or imagine waiting for a message from someone you care about. A part of you believes they'll reach out. Another part fears they won't. You live in both feelings at once, hope and doubt, until your phone lights up. And then, like a switch, the reality becomes clear. Before you checked, you were living in many futures. After you looked, only one remained. Superposition is about potential. And the collapse? That's the moment the potential becomes reality. It's a reminder that possibility is fragile. It lives in silence, in waiting, in not knowing. And sometimes, once we look too closely, once we ask the question, the mystery ends. This idea flows into relationships, too. There are times when we're unsure about someone's feelings. We feel they might care, or they might not. We hold both thoughts quietly. But the moment we ask, "Do you feel the same?" the wave collapses. Their answers shape everything. Before that moment, we lived in all possible outcomes. Afterward, only one remains. In a way, superposition is a space of magic. It's the space where all futures still exist, where dreams aren't yet lost, where answers haven't been spoken. But it's also a space of tension, because we cannot live there forever. Sooner or later, we look, we ask, we decide, and the universe responds. Even in belief, this paradox finds a place. Many people walk through life carrying questions about, meaning about purpose, about what comes next. Some find comfort in choosing a belief. Others find peace in not knowing. But everyone at some point faces a moment of collapse, a moment where they must choose a path, even if it's just for a while. And when they do, all the other answers become quiet. In language, we see this too. Words begin in thought. Before we speak them, they exist in many forms. Should I say this kindly or firmly? Should I stay silent? We feel the possibilities in our chest spinning quietly. But when we speak, when the word leaves our mouth, we collapse the wave. One version becomes real, the rest fade. Mental health carries this feeling deeply. People often live in a fog of thoughts. They might feel both numb and overwhelmed. They may not know what they're feeling at all, and that space can feel frightening. But it's also a space of superposition, where healing is still possible, where identity is still forming, where the mind holds more than one truth. Recovery, too, is a collapse. It's a gentle movement toward one shape of self, a settling, a becoming. Even artificial intelligence reflects this paradox. Before a program responds, it holds many possible outcomes, words, thoughts, actions, all suspended for a breathless moment. And then, a choice is made. The code runs. The answer is born. The potential collapses into the actual. So what can this strange behavior of particles teach us about our lives? Maybe it tells us that it's okay not to know, that we don't have to have all the answers right away, that we can sit in the middle of maybe for a little longer, letting the future unfold gently. Maybe it reminds us that possibilities are not lies. They are real, even if they don't last. That imagining more than one future isn't weakness, it's wisdom. It means we're still open, still searching, still alive. And maybe it comforts us to know that choices will come. And when they do, it's okay to let some possibilities go. The collapse isn't a failure, it's just the next step in the story. So tonight, as you rest, if your mind is swimming with choices, with paths not taken, with futures not yet clear, breathe. You're in superposition. And that's okay. You don't need to rush toward certainty. Let the wave hold you for a while. And when the moment comes, when you're ready to look, to speak, to choose, your reality will unfold, and the rest will gently fade, not lost, just released. If you've ever felt that strange tension between all the things you could be and the one you must become, share your story in the comments. Let others know they're not alone in that quiet space of maybe. And if this helped you relax, helped you reflect, or just helped you feel a little more human, please like this video. Subscribe for more gentle stories, told in simple words, stories that help us sit with the unknown and smile. Thank you for being here, for choosing stillness, for being part of this wave, before it becomes something else. Particle, anti-particle. Have you ever met someone who felt like your complete opposite? Yet somehow it felt like you were deeply connected, like they were your mirror. Maybe it was a friend, a stranger, or someone you once loved. You were light, they were shadows. You were calm, they were wild. And even though you were so different, it felt like your paths were meant to cross, if only for a short time. And when you parted ways, it was as if something inside you disappeared with them, leaving only silence. Have you ever felt this strange connection before? A bond that felt both beautiful and temporary? Share it in the comments if you feel like it. And let us know where you're watching from tonight. You never know. Someone far away might be feeling the same way. In the quiet world of quantum physics, there's a mysterious truth that carries this feeling. Every tiny particle in the universe, every electron, every proton, has a twin. But not just any twin. It's called an antiparticle, a perfect opposite, a kind of mirror self. They have the same mass, the same size, but opposite charges. One leans one way, and the other leans the other. And here's the strange part. When a particle and its antiparticle meet, they don't blend, they don't combine, they vanish instantly. In a silent flash of energy, they both disappear. Everything that made them different, everything that made them whole, melts into light. No trace remains of their form. Only the energy lingers. It's almost poetic, isn't it? Two opposite beings drawn to each other, only to vanish in the moment they truly meet. Not in destruction, but in release, a kind of surrender. You might wonder, how can something so small carry such emotion? But maybe it's not just about physics. Maybe it's about us, too. Think about the people who've come into your life and left quickly, the ones who felt like reflections, who saw parts of you that no one else did. Maybe you laughed with them like you'd known them forever. Maybe you argued like fire meeting ice. But it was real, and intense, and brief. When you parted, it wasn't because you didn't care. Sometimes it's just that some people aren't meant to stay. They were meant to show you something, to awaken a part of you, and then disappear, just like a particle and its mirror twin. Or think of those moments in life when you feel pulled in two directions. Part of you wants to stay, part of you wants to go. You feel full of energy, torn, alive. These two sides live inside you, opposites that shape who you are. And yet, in certain moments, they meet, they touch, and just like that, the tension vanishes. A decision is made. A path is chosen. The rest fades into quiet. It happens in relationships too. There are people we're drawn to not because they're like us, but because they're not. They challenge us. They stretch us. They mirror the parts we don't understand. And sometimes loving them means letting them go. Not out of anger, but because the connection burned so bright it couldn't last. It had to become something else, a memory, a lesson, a flash of light. In belief systems, we see this dance as well. Faith and doubt, certainty and mystery. Many people carry both at once, and when they truly confront each other, something shifts. It's not about winning or losing, it's about transforming energy, moving from confusion to peace, from silence to light. Even language carries this idea. Every word has a shadow. Say always, and you feel never. Say yes, and somewhere the no echoes. But in the space between those opposites, there's something beautiful, a balance, a pause. And sometimes, when we stop trying to choose, both sides fall away. What's left is understanding, a quiet light that doesn't need to explain itself. In the mind, this paradox lives deeply. People often hold two truths that seem to cancel each other out. I feel strong. I feel broken. I want to be seen. I want to disappear. These thoughts feel like they shouldn't exist together, but they do. And that's okay. When those inner voices finally meet, when the mind no longer hides from itself, there's often stillness, a soft release. Not everything is solved, but the struggle becomes light, and that light can guide healing. Even in the design of artificial intelligence, we see echoes of this pattern. Programs are trained on data from many directions: kindness and cruelty, joy and sorrow, truth and fiction. But in the end, what's created isn't just the sum of opposites. It's something new, a response, a path forward, a gentle light from the middle of the storm. So what does this mean for us? Maybe the particle-antiparticle dance is a quiet reminder that not every meeting is meant to last. Some connections burn bright, then vanish, but they still leave warmth. They still light the way. Maybe it shows us that opposites aren't enemies. That tension isn't always something to fight. Sometimes it's something to witness, to honor, and to let go when the time comes. Maybe it tells us that being human means carrying contradictions, loving and fearing, hoping and doubting, holding on and letting go. And maybe that's not a problem to solve, but a beauty to live with. Because when these opposites meet inside us, when we stop running and let them face each other, they don't destroy us. They don't make us disappear. They make us shine. So tonight, if you're thinking of someone who once felt like your mirror, someone who came into your life and changed everything, even for a moment, know that it mattered. Even if they're gone now. Even if you never said goodbye, that light they left behind, it's still with you. And if you're feeling two things at once right now, love and fear, joy and sadness, movement and stillness, breathe. Let both exist. You don't have to choose right away. Just let them meet and watch what happens. Thank you for being here tonight, for sharing this quiet space with me. If this helped you reflect or brought you some peace, please like the video. Subscribe for more gentle stories and share your thoughts in the comments. Your stories, your mirrors, your flashes of light. Wherever you are in the world, you are not alone in this dance. We're all made of particles and opposites, and we're all searching for the quiet light that lives in between. Quantum walk. Have you ever walked through your house at night with the lights off, just guessing your way through the dark? Maybe you bumped into a chair, turned left too early, or found yourself in the kitchen instead of the bathroom. You took step after step without knowing exactly where you were going. And yet, somehow, after enough steps, you still ended up right where you needed to be. Like your body had its own kind of memory, even when your eyes couldn't see. Have you ever had a night like that? A strange path through darkness that somehow led to a familiar place. If you have, or even if you felt lost in life but kept moving anyway, I'd love to hear your story in the comments. And feel free to share where you're watching from. This community stretches farther than we can see, like steps taken in a dream. Now, imagine something much smaller than you. A tiny bit of light, called a photon. Picture it like a small spark, wandering through space. You'd think, because it's so small, it should move in a straight line, or at least follow a clear path, like a train on tracks. But in the strange world of quantum physics, this little photon behaves differently. It takes what scientists call a quantum walk. That means it doesn't just walk left or right, forward or back like we would. Instead, it takes every possible path at once. It spreads out like ripples in a pond. It's like the photon is wandering, unsure, stepping this way, then that, over and over, almost like it's had one too many drinks. That's why some people compare it to a drunk walk. But here's the twist. Even though its steps are random, completely unsure, completely without plan, the final pattern it creates isn't random at all. It's organized. It's beautiful. The chaos somehow turns into order. No one tells it where to go. No one guides it. But it still ends up drawing shapes that can be predicted, calculated, even expected. How can something that moves with no clear direction create something so elegant? It's a mystery. And yet it feels familiar. Because sometimes life feels like a drunk walk, too. You might wake up one morning and have no idea what direction to go in. You apply for jobs and hear nothing. You try to fix a relationship, but the words never come out right. You start one project, then another, then quit both. Some days, just getting out of bed feels like a step in a fog. But then, a month later, a year later, you look back, and somehow it all fits, like all those lost steps led somewhere, like your wandering had meaning even if you couldn't see it at the time. Have you ever felt that? That strange moment where things fall into place, even though the path there made no sense. This is the heart of the quantum walk. It tells us that even when we feel lost, even when our steps feel scattered, something deeper might be at work. Not in a magical way, but in a quiet, mysterious way. A pattern forming beneath the surface, a rhythm behind the noise. It shows up in small ways too. Think of when you misplace something and search every room of your home, touching every drawer and pocket, only to find it sitting right on the counter where you started. Or when you study 5 chapters for a test, and only the one you skimmed ends up on the paper. You could call it bad luck. Or maybe it's just the quantum walk of life, taking steps that feel wrong, only to find they led you somewhere meaningful. Even emotions walk like this. You might feel joy one moment and sadness the next. Hope in the morning, doubt by dinner. You're pulled in different directions. You're not broken. You're just walking the inner quantum path. You're feeling all the things, letting yourself step left, step right, pause, spin, fall, rise, and maybe that's how healing happens. Not in a straight line, but in the wild steps that finally lead you home. Language, too, carries this strange walk. Sometimes you say something and it comes out wrong. Other times, a simple sentence you barely meant becomes the one thing someone needed to hear. Words step in all directions. Some disappear, some echo, and some, no one planned, leave a mark that lasts forever. In relationships, the walk can be just as strange. We meet people by chance, on buses, in classrooms, through missed calls. Some enter our lives through what feels like an accident, and yet they stay, or change us, or teach us something no one else could. And again, we wonder, was that randomness, or part of the quiet pattern we didn't know we were drawing? Even AI, in some ways, is built on this kind of walk. It learns by testing paths, by trying, failing, adjusting. It doesn't always know where it's going, but over time, a shape begins to form, a pattern that feels intelligent. And just like the photon, it reaches somewhere surprising by moving in ways no human would plan. So what does this mean for us? Maybe it means we don't have to fear the days when we feel unsure. Maybe we don't need every step planned out. Maybe we can trust that wandering isn't wasted, that getting lost isn't failure, that the path only looks messy up close. But from far away, it's drawing something beautiful. Maybe it tells us to keep going. Not because we know where we're headed, but because the walk itself is what brings the shape to life. Tonight, if you're feeling a little lost, if your steps feel uncertain, know that you're not alone. We're all walking through some kind of fog, all trying to find meaning in the middle of randomness. But just like that little photon, your movement matters, even if it looks messy. The pattern will reveal itself in time. Thank you for walking with me tonight, for pausing in your own path to rest in this quiet moment. If this brought you peace or helped you see your steps in a new way, please like the video. Subscribe for more soft reflections like this one, and feel free to leave a comment. What's your story of walking without a map and still finding your way? Wherever your next step leads, trust that it matters. You don't have to see the whole shape yet. Just keep moving. Even in randomness, the light finds a way. Delayed entanglement. Have you ever reconnected with someone from your past, maybe a childhood friend, an old neighbor, or a former colleague, and felt an instant closeness as if you'd never truly been apart? You haven't talked in years, yet when you finally speak, it's like no time has passed. You complete each other's sentences, share the same memories, and feel a sudden spark of understanding that surprises you both. It's almost magical, like a secret bond that waited patiently for its moment. In the quantum world, there's a phenomenon that captures this same mystery, called delayed entanglement. Two particles can become linked, entangled, long after they've stopped interacting directly. It's as if the universe itself remembers their connection and brings it back to life when the time is right. If you've ever felt a sudden reconnection with someone from your past, I'd love to hear about it below. Share your experience and let us know where in the world you're watching from. In these simple moments, we find a deep sense of community, reminding us that we're all woven together by unseen threads. Imagine two particles born together, partners created in the same instant. In their early moments, they share a hidden link, but then they separate. One might travel across the room, the other drifts away in another direction. They might interact with other particles, get jostled, measured, even changed. For a long time, they exist as strangers in different places, yet, under the right conditions, they can become entangled again, long after their first meeting. It's like being reunited after years apart and discovering that the bond you once had is still alive, waiting to be reawakened. This reentanglement doesn't require particle A and particle B to bump into each other again. Instead, they each meet other particles, let's call them C and D, in carefully arranged ways. Through these new connections, A and B find their way back to each other's story. Suddenly, a measurement on A reveals something about B, even though they haven't directly touched in ages. The link skips across time and space, whispering that their shared history still matters. In our lives, we feel this too. Think of someone you've lost touch with, a cousin you haven't seen since childhood, or a classmate who moved away. Years might pass. You both live different lives. Then, unexpectedly, you reconnect, maybe through social media or a chance meeting at a coffee shop. You talk for hours as if no time has passed. That shared past becomes the bridge, bringing you back together. The connection, once silent, springs to life again. Even simple examples show us this pattern. Imagine a beloved song you haven't heard in years. One day, it plays on the radio, and you're suddenly transported back to a specific summer, a certain friend, a moment of laughter. The song's notes re-entangle you with a memory you thought was lost. In that instant, your present and your past become one. This paradox of reconnection reminds us that some bonds don't break. They just lie dormant until the right spark. It teaches us to treasure our shared moments, because even if they fade, they never disappear completely. They're waiting in the quiet spaces of our hearts. In relationships, delayed entanglement can feel like fate. You might meet someone new who shares a surprising number of your interests and memories, almost as if you grew up side by side. Even without a direct link, your lives seem to overlap in uncanny ways. It's as though life arranged a series of small encounters to rebuild a connection you didn't know was missing. This idea echoes deeply in healing and growth. Sometimes we think we've moved on from a painful chapter, left it behind in another time and place. Yet a familiar scent, a song, or a gentle word can bring that old self back to the surface. In that moment, we feel the parts of us we thought were gone. We realize healing isn't about erasing the past. It's about weaving it into our present, letting old pieces find new life. Language carries this pattern as well. A phrase you learned as a child may resurface years later in a conversation, instantly unlocking a memory. Or a word you created to comfort yourself long ago can quietly reappear in your thoughts when you need it most. These linguistic entanglements remind us that the words we use and the stories we tell have lives of their own, capable of reuniting us with forgotten parts of ourselves. In belief systems, many traditions speak of reunion, souls meeting again after many lifetimes, or spirits returning in different forms. While quantum physics doesn't speak of souls, it does show that connections can transcend direct contact. The universe seems to hold on to relationships, ready to re-establish them when conditions align. This also touches mental health. We might believe we've left a difficult time behind, depression, anxiety, a grief that feels endless. Then, much later, a sudden thought or feeling re-entangles us with that old pain. It can feel like regression, but it can also be an opportunity to recognize how far we've come and to bring new understanding to an old wound. The reconnection is not a failure, it's a chance to heal more deeply. Even in technology and AI, there are reflections of delayed entanglement. Machine learning models sometimes revisit old data to improve accuracy. They reaccess past information in light of new patterns. In a way, they are entangled with their own training. discovering fresh insights long after the data was first fed. So what can we take from this quantum surprise? Perhaps that every encounter matters. Even if it feels fleeting, the threads we weave today may reappear years from now, creating new patterns in the fabric of our lives. That person you meet for 5 minutes could become someone you remember for years. That smile you share could spark a bridge back to an old memory. That kindness you offer might one day return to you in a form you never expected. When you feel disconnected, remember that reconnection can happen. It might come through an unexpected message, a chance meeting, or a silent memory that suddenly bursts into clarity. The bonds we form, like particles in the quantum world, can linger, ready to be reawakened. If this reflection resonates, please like this video and share your own stories of reconnection in the comments. Let us know where you are watching from and help build a gentle space of shared wonder. And if you'd like more of these calming journeys into the mysteries of the universe and the heart, subscribe to the channel. Hit the bell so you don't miss our next thoughtful exploration. Thank you for joining me in this quiet moment of reflection. Remember, the universe holds on to connections in ways we can barely imagine. Sometimes, when the time is just right, it brings them back, reminding us that nothing is ever truly lost as long as the spark remains. Spin paradox. Have you ever felt that no matter what choice you make, someone else somehow ends up making the exact opposite choice without even talking to you? Like picking chocolate, and a friend across the table must choose vanilla. It feels as if the universe is mirroring your decision in reverse. This curious dance of opposites is more than just a trick of human nature. Deep in the world of quantum physics, there's a phenomenon called the spin paradox, where two particles share a hidden link. Measuring one particle's spin instantly forces its twin to spin the opposite way, even if they are miles apart. It's a gentle reminder that connection can exist beyond sight, beyond talk, and even beyond common sense. Have you ever experienced that strange tug of mirrored choices in your own life? Maybe in friendships, family decisions, or simply in the way you and someone close always seem to pick the reverse of each other. If so, share your story in the comments and let us know where you're listening from. There's a quiet magic in discovering how we too can reflect one another without a single word exchanged. To understand the spin paradox, imagine two tiny particles, call them electrons, born together in a single event. From that moment, they become entangled, bound by a secret connection. You send one electron off to the North Pole and the other to the South Pole. Light years apart, they no longer interact in any normal way. You could measure the spin of each one, whether it's spinning up or down. But here's the magical part. If you measure the north electron and find it spinning up, the south electron immediately takes on the opposite spin, down, before you even look. It's as if the act of observation at one end gently whispers to the other, "Now spin the opposite way." This remarkable behavior defies our everyday ideas of cause and effect. We're used to messages traveling at a finite speed, nothing faster than light. Yet here, change seems to happen faster than any signal can move. Albert Einstein famously called it spooky action at a distance. He couldn't believe it, but repeated experiments have shown that it's real. When two particles are entangled, they remain mirrors of one another, bound by a connection that transcends space. This paradox resonates deeply with the ways we connect as people. Think of a time when you and a friend made opposite decisions without planning it. A pair of flip-flops, one bold, one calm, one person wanting quiet, the other seeking energy. Sometimes in relationships, we deliberately take opposing roles to balance the dance. One leads, the other follows. Without words, we find rhythms that keep us in harmony, even in contrast. In friendships, this mirrored dance can be playful. You pick a movie, your friend instantly chooses something different. Over time, you learn to appreciate your friend's counterpoints, and the two of you discover a wider range of stories together. Through divergence, you share new perspectives, enriching both your worlds. In this way, the spin paradox becomes a gentle lesson. Balance often lives in opposition. Even simple choices at home show this pattern. You open the fridge for a snack, your partner closes it without taking anything. You're craving sweets, they reach for salt. You flip the light on, someone flips it back off. In small ways, we mirror one another's moves, creating a dynamic tension that keeps relationships alive. It's not disagreement for its own sake, it's a dance of difference, where each choice shapes the shared space. In the context of exams or work, the spin paradox teaches us about balance too. When one student leans heavily into memorization, another leans into understanding concepts deeply. They arrive at similar results, learning, but through opposite approaches. This contrast can be a gift. As they share notes, each sees things the other missed. In a way, their minds become entangled, helping each other fill gaps and expand. Insight. Even the weather plays this out. A sunny day in one city can mean cloudy skies in another just 30 miles away. Sunlight reflects off clouds, sending light in all directions, yet those clouds also cast shadows miles away. Nature's own spin paradox reminds us that conditions can be opposite, but linked by larger patterns we barely notice. In our beliefs, the paradox whispers softly. We often define ourselves by what we are not. I am not my fears, one might say. I am not my doubts, another might affirm. Yet, in those denials, we shape our true selves. By recognizing what we oppose, we discover who we really are. That mirrored reflection, of up and down, of here and there, is a path to self-knowledge. Language holds the paradox in its words. Every yes contains a hidden no. Every statement of certainty hints at doubt, and sometimes we speak to hear the echo of the opposite. We need contrast to understand meaning. Like two particles spinning in reverse, words and silences play off each other, weaving a tapestry of thought. In mental health, the spin paradox can show us kindness and compassion. When someone feels stuck in negativity, a gentle push toward positivity, an opposite spin, can open a new way. And sometimes the reverse is true. When someone is overwhelmed by forced positivity, a kind recognition of their pain provides balance. In those moments, the mirror of opposition becomes healing. We see that we're not alone in our struggles, because someone else feels what we cannot admit to ourselves. Even in artificial intelligence, echoes of the spin paradox appear. Machine learning models adjust weights and biases in opposite directions to find balance in their predictions. When one pattern fails, the system flips its settings and learns from the opposite. Through these mirrored adjustments, the AI reaches a more balanced, nuanced understanding of data. So what does this quantum dance teach us? Maybe it reminds us that connection often lives in contrast. That two people, two ideas, or two feelings can be opposite at the same time and still be deeply linked. That harmony isn't always found in similarity. It sometimes shines brightest in difference. The next time you find yourself making a choice, opposite someone you love, toast when they have cereal, quiet when they're loud, pause for a moment. Recognize the hidden bond in your divergence. Notice how you shape each other's experience, even without words. In that mirror of contrast, you glimpse the unseen threads that weave you together. If this spark of curiosity warmed your evening, please like this video, and if you've ever felt that mirrored connection in a relationship, a memory, or a small daily choice, share it in the comments below. Let us know where you're watching from and help us build a gentle community of reflection. And if you'd like more of these calming, thought-provoking journeys through the mysteries of science and soul, subscribe to the channel. There is much more to explore, each paradox a quiet path to wonder. Thank you for being here, for joining in this gentle reflection, and for recognizing that sometimes the most powerful bonds glow in the subtle dance of opposites. In every spin and every mirrored choice, there is a secret connection waiting to be felt. Quantum interference. Have you ever noticed how people act differently when they know they're being watched? A child suddenly behaves more carefully when a parent enters the room. A person walking alone might hum softly until someone else appears and silence follows. There's something deeply human about how observation changes behavior. But this strange truth isn't limited to people. It seems even the tiniest parts of reality, like particles of light or matter, change how they behave depending on whether anyone is watching. It's almost as if the universe, too, is shy. Have you ever felt like someone watching you made you act in a way that didn't feel natural? Maybe during an exam, a job interview, or even while walking past a group of people. If so, you're not alone. Share your story in the comments and tell us where in the world you're listening from. You might be surprised how many others have felt that quiet pressure too. Now, imagine this. A tiny particle, so small you can't see it, is sent through a pair of narrow slits. On the other side is a wall, and as the particle hits it, it leaves a mark, just like rain tapping on a window. But something strange happens. If we don't watch which slit the particle goes through, it doesn't behave like a solid dot. Instead, it acts like a wave. It passes through both slits at once, creating a pattern of light and dark on the wall. A ripple, like waves meeting and canceling each other out in water. This is called an interference pattern. It's not what you'd expect from something so small and solid. It's more like what you'd expect from light or sound or waves in the sea. It's as if the particle is not just in one place, but in many places at once. It flows, it dances, it explores possibilities. It becomes a wave of chance. But here's the twist. As soon as we try to watch the particle, by placing a detector near the slits, it stops behaving like a wave. It chooses just one slit. It becomes a dot again. The interference pattern disappears. That flowing, dreamy behavior vanishes. Observation forces the particle to pick a side. It can no longer be in two places at once. It must be committed. This is quantum interference, a paradox where watching something, just trying to know more about it, changes its nature completely. It's as if attention itself reaches into the heart of reality and shifts it, not by touching or pushing, but just by looking. Think about that for a moment. Our desire to know changes what is. Awareness changes outcome. This is more than physics. It touches the way we think, feel, and relate to others every single day. In relationships, we often see this quietly play out. Someone may act warm and open when left alone, but become guarded when questioned too closely. A child may learn freely through play, but stumble when tested under a watchful eye. Even in love, we can sometimes lose our natural rhythm by overanalyzing. Trying too hard to understand someone can push away the very closeness we seek. In these moments, like the particle, people shift when they know they're being seen. Or consider creativity. Many people feel ideas flow easily when no one is around. Artists and writers often say their best work happens late at night, when the world is quiet and no one is watching. But when a deadline looms or an audience waits, the flow becomes harder to reach. Attention, even imagined, can make thoughts freeze. Like the particle forced to choose a path, the creative mind narrows under pressure. Even something as simple as sleep carries this feeling. Have you ever tried hard to fall asleep, only to find your mind refusing? You focus on the act itself, and it slips away. But when you let go, when you stop watching your thoughts, they slow, they soften, and sleep gently arrives. It's the wave again, appearing only when not observed. The same thing happens in exams. A student may understand a topic deeply in private, but under the eyes of a teacher or the ticking of a clock, the answers seem to disappear. Confidence shakes, memory stutters. The act of being watched changes performance. This is not just nerves. It's a reflection of the deeper rhythm of how observation shapes reality. In language, too, we can feel this paradox. Words spoken in privacy may carry deep meaning, while those spoken in public may feel polished, controlled. Just like particles in the double-slit experiment, our thoughts can exist in multiple layers when unobserved. But as soon as we try to express them under pressure, They collapse into one clear, limited path. In mental health, this idea brings both challenge and comfort. Sometimes just naming a feeling, watching it, can change it. A feeling of anxiety, when observed gently, may start to shift. But other times, paying too much attention to our worries makes them stronger. Like the quantum particle, feelings sometimes need space, not focus, to move freely. The act of simply being with an emotion, without judgment or deep inspection, allows it to flow and settle naturally. Even artificial intelligence mirrors this paradox. Some systems adjust based on user feedback. They behave differently when being tested than when left alone to run. The presence of an observer changes the pattern of response. It's a quiet echo of quantum interference, seen not in light, but in code. So what does this all mean for us? Maybe it teaches us to be gentle with observation, that there is a time to watch and a time to simply let things be, that not everything reveals itself when stared at too closely, that truth, like beauty, sometimes arrives quietly in the spaces where no one is looking. It reminds us to respect the unseen, that within the invisible spaces of thought, feeling, and possibility, reality is still unfolding. That presence matters, that how we look, not just what we look at, shapes the outcome. The next time you feel watched, whether by others or by your own inner critic, remember the particle. Remember that you too have a wave inside you, a side that flows when no one is judging, a self that shines most clearly when allowed to simply be. And when you feel pressure to choose a single path, to collapse into one clear direction, pause, take a breath, allow the wave to move through you, let possibility unfold. If this reflection sparked something in you, please like this video. Share in the comments if you've ever felt changed just by being watched, and let us know where you're listening from. You're not alone in that feeling. There's a whole world of gentle souls out there, each discovering the quiet mystery of being. And if you'd like to wander deeper into the calming wonders of science, self, and the strange beauty of the universe, subscribe to the channel. There's more to explore, more gentle ripples to follow. Thank you for joining me in this quiet moment. May your evening be calm, your thoughts gentle, and your heart open to the mystery that even the smallest things can behave like waves when we simply stop watching. Measurement problem. Have you ever checked on something only to find it changes the moment you look? Maybe it's your phone battery that suddenly drops just as you check it, or your mood, which seems fine, until someone asks how you're feeling, and suddenly you're not so sure anymore. It's strange, isn't it? As if the very act of noticing something causes it to shift, like chasing a shadow that dances away the closer you get. Have you ever felt that way? Like the answer was clear until you tried to measure it? Maybe during a test, a difficult conversation, or even while trying to fall asleep. Let us know in the comments if you've experienced this. And share where in the world you're watching from. It's comforting to know how many people feel the same subtle shifts in everyday life. Now imagine this. At the smallest levels of the universe, where particles like electrons and photons live, things don't behave in the way we expect. In everyday life, we assume that things have a position, a speed, or a shape, even when we're not looking. A cup remains a cup, whether it's on your table or behind a curtain. But in the quantum world, things are different. A particle doesn't seem to choose its position or its path until someone tries to measure it. Before that moment, it exists in a cloud of possibilities. It could be here, there, or somewhere in between. This is the mystery at the heart of the measurement problem. In simple words, when we try to observe something in the quantum world, we change it. Our attempt to find out where it is, or how it behaves, forces it to make a choice. The act of looking collapses the cloud of possibilities into a single outcome. But here's the strange part. We never see that cloud. We only ever see the result after we've measured it. So we start to wonder, was the particle really there before we looked? Or did our measurement bring it into being? It's like trying to study a dream. The moment you wake up and try to remember it, the dream slips away or reshapes itself. The act of grabbing it, trying to capture it, changes it. The more you try to hold it still, the more it shifts and fades. The truth, whatever it was, moves like mist in the morning light. In our daily lives, we feel this too. Think of friendships. Sometimes a friendship works because we don't constantly analyze it. The connection flows naturally. But the moment we start questioning it, asking where we stand, what it means, where it's going, the warmth can change. Not always for the worse, but it becomes something different. Like the particle, the relationship picks a shape once we try to measure it. Or think about feelings. You might feel peaceful for no reason, but then you start wondering, why am I calm? Should I be doing something right now? Am I missing something? Suddenly the calmness disappears. The moment you tried to define it, it slipped through your fingers. Even in exams or competitions, we see this. A student may know everything during study sessions, but under the pressure of measurement, a test, a grade, a comparison, the knowledge wobbles, confidence stumbles. The result is different just because it's being judged. And sometimes we do this to ourselves. We try to measure our worth by looking at likes, followers, achievements. We search for numbers to define us. But the more we look, the more we feel unsure. Because no number can fully capture who we are. The act of measuring ourselves changes how we feel about ourselves. The measurement problem is not just a scientific puzzle. It's also a reflection of something deeper in how humans live and think. We seek truth. We seek certainty. But the closer we look, the more we realize that truth can shift. That knowing something doesn't always mean understanding it. That sometimes the act of asking the question changes the answer. Even in belief systems, this idea can be felt. When we try too hard to define what we believe, what is right, what is wrong, we may find our beliefs become rigid or uncomfortable. But when we allow space for mystery, for questions, for things we can't yet explain, our beliefs breathe and grow. The same goes for language. Words are meant to help us express the truth, but they can also limit it. When we try to describe something vast like love or grief or awe, we often feel that words fall short. The truth is larger than language can hold. By trying to pin it down, we sometimes lose the feeling itself. Even technology and artificial intelligence reflect this. Systems behave differently depending on how they're trained, tested, or observed. A program that performs well during development may falter when it meets the real world because the act of testing creates a different environment than the one it's built to serve. Measurement changes outcome, even in machines. So what can we learn from this quiet paradox? Maybe it reminds us to hold truth with soft hands, to let go of the need to always measure, define, and explain. Sometimes being present is better than being certain. Sometimes trusting the feeling is wiser than naming it. It also reminds us to be kind to ourselves and others. Because what we see is not always the full picture. The moment we start measuring someone, judging their performance, questioning their choices, we may change the very thing we're trying to understand. By simply being there, without pressure or need to define, we allow people to show their truest selves. And maybe it encourages us to slow down. In a world that rushes to measure everything, progress, happiness, success, we can choose a different rhythm. One that honors the unknown, that finds peace in not always knowing, that allows wonder to stay a little longer before we try to name it. So the next time you find yourself chasing a clear answer, trying to pin down a feeling, or judging yourself by a number, remember the measurement problem. Remember that even the smallest parts of nature resist being captured. That truth can live in the quiet space before measurement. If this gentle mystery stirred something inside you, please like this video. Tell us in the comments if you've ever noticed this in your life, a time when trying to understand something changed it, and let us know where you're watching from. You're part of a thoughtful, calm community here. And if you enjoy these slow walks through science, feeling, and the strange beauty of the world, don't forget to subscribe. There's always more to explore. Together. Thank you for sharing. this moment. May your night be soft, your thoughts light, and your heart open to the mysteries that can't always be measured. Weak measurement. Have you ever listened in on a conversation without fully hearing every word? Just enough to catch the mood, the tone, maybe a few hints of what's going on, without really disturbing the moment? Sometimes not knowing everything feels more peaceful, as if truth is something we can gently approach without needing to grab it with both hands. Have you ever had a moment like that, when you knew just enough to feel close to someone or something, but you didn't need to understand it completely? Maybe in a quiet moment with a friend, a song that brought tears without clear reason, or even a memory you don't fully recall but still feel. Let us know in the comments if you've had an experience like that and where you're watching from. This space is filled with curious minds and calm hearts. In the strange world of quantum physics, there's a quiet idea that mirrors this feeling. It's called weak measurement. Imagine you want to understand something, but without scaring it away, without interrupting its natural flow, like watching a deer from far away in the woods, careful not to snap a twig. You still see it, you still feel its presence, but you don't fully disturb it. In the quantum world, when we measure something, like the position or energy of a particle, we often collapse its possible states into a single one. It's like shining a bright flashlight into the dark. You get a clear picture, but you change what you're looking at. The particle reacts. It picks a side. The mystery disappears in favor of certainty. But with weak measurement, it's different. Instead of blasting the scene with light, we let a soft glow fall across it. The result is not a sharp answer, but a gentle clue. We don't collapse the full wave of possibilities. We just nudge it a little. We whisper rather than shout, and somehow, even in the quiet, we learn something. Think about relationships. Sometimes you don't ask the hard questions. You don't force clarity. You just sit beside someone, listen, and notice. A pause in their voice, a shift in their eyes. These soft details don't give you the full story, but they speak volumes. You understand enough to care, enough to stay. That's a weak measurement in human form. Or take your own thoughts. Maybe you felt sad, but don't know why. You didn't push for answers. You just sat with the feeling. Let it rise and fall, like waves. And in that silence, you found peace. Not by solving it, but by noticing it gently. That, too, is a kind of weak measurement. You saw just enough to connect with yourself. This idea can touch many parts of life. In art, for example, a soft pencil sketch can say as much as a detailed painting. The beauty lies in the suggestion, the open space. What's not shown is just as important as what is. It leaves room for imagination, for mystery. Even in learning, sometimes we take in knowledge slowly, quietly, reading without taking notes, listening without needing to remember every fact. These moments still teach us, often more deeply than tests or quizzes. Because we're not trying to measure the knowledge, we're simply sitting with it, letting it settle. In mental health, there are times when we don't want to be fixed. We just want to be heard. A friend who listens without judging, without solving, gives us a soft kind of healing. Their attention is a weak measurement. It doesn't collapse us into a single state, like happy or sad. It allows us to do many things at once. That's powerful and kind. Even technology, like artificial intelligence, is moving in this direction. Some systems now learn by watching patterns quietly instead of being fed huge amounts of sharp labeled data. They notice rather than demand. And in that, they become more human, more able to understand subtlety. Weak measurement teaches us something gentle but deep. That we don't always need full control, that we can live with partial truths, with hints and whispers, that life doesn't have to be solved like a puzzle. Sometimes it's enough to just be near the mystery, to walk beside it, not inside it. When we do this, we let things be. A flower doesn't bloom faster because we stare at it. A child doesn't grow more confident because we test them daily. Some things thrive best under quiet attention. A soft gaze, a light touch. So if you've ever felt the need to understand something completely, to define every feeling, solve every problem, or find every answer, maybe this idea can help you rest. Weak measurement reminds us that not everything wants to be measured. Some truths arrive slowly, some feelings don't want to be named, and some moments are richer when left a little undefined. If this reflection touched something in you, please like this video. Share your thoughts in the comments. Have you ever learned something just by noticing softly, without pushing? And tell us where you're watching from. It's peaceful to know we're exploring these mysteries together. And if you enjoy these quiet walks through strange and beautiful ideas, don't forget to subscribe. There's always more to see, and more to feel, when we slow down together. Thanks for spending your time here. May your thoughts be light, your heart be open, and your night filled with the quiet truth that not all things need to be known completely to be understood. Quantum eraser. Have you ever wished you could unseen something? Maybe you read a message that changed how you felt about someone, or heard a comment that stuck with you for days. It's strange how just knowing something, one small fact, can change your entire view of a moment. And even stranger, how forgetting that fact, or letting it go, can sometimes bring peace again. Almost like your mind rewrites the story, once the weight is lifted. Have you ever had an experience like that, where knowing too much made everything feel different and forgetting brought something back? Let us know in the comments, and share where you're watching from. This little space is a quiet home for curious minds across the world. Now imagine that same feeling, but in the world of particles and light. In physics, there's something called the quantum eraser. It's one of those ideas that doesn't just sound poetic, it really is. And it all starts with a question. How much does knowing something actually change what is? Let's begin with a simple experiment. Imagine a beam of light. That light passes through two small openings like tiny doorways on a wall. Behind the wall is a screen. Now, if you don't do anything else, the light will make a strange pattern on the screen. A pattern of waves, bright and dark stripes. This means the light is acting not like little pieces, but like a soft ripple in water, interfering with itself. But here's the twist. If you try to find out which opening the light actually went through, just by putting a tiny detector next to one of the paths, the pattern disappears. Suddenly, no more waves. The light behaves like little bits again. It stops acting like a mystery and picks a side. That's already strange. But the quantum eraser makes it even more unbelievable because you can choose to erase that which path information after the light has already passed through. Yes, after the fact. And when you do that, when you erase the knowledge of which way it went, the wave pattern comes back, as if the light somehow knew that you no longer knew. It's like going back in time, but not to change what happened, just to change what's knowable, and reality responds. It's almost as if the universe doesn't decide what's real until you decide what's knowable. The act of forgetting brings back the mystery. It brings back the beauty. Let's slow down here. Think about how this shows up in life. Maybe in a friendship. You learn something, a secret, a rumor, a truth, and it changes how you feel. Suddenly things aren't soft anymore, they become hard, sharp, clear. But then, time passes. You forget the details. The pain fades. And the connection comes back, gentle and warm, like it was before. Or think about childhood. We forget so much of it. But in that forgetting, something soft returns. Wonder, joy. A feeling that anything is possible. Maybe it's the unknowing that gives life its shimmer. Maybe it's the erasing that brings the light back. Even in exams or learning, this idea shows up. If you focus too hard on every detail, trying to remember everything, you miss the bigger picture. But when you step back, let go of what you have to know, something deeper clicks. Understanding happens when pressure fades, when knowing isn't forced. The quantum eraser shows us something powerful, that the universe might not be about hard facts. It might be about awareness, about attention, about what's possible, not just what's fixed, and in that way, it mirrors our inner world too. Our thoughts, our memories, our feelings, they shift depending on how much we focus. And when we forget, we often feel free again. Some scientists argue over what's really going on here. Is the universe really changing based on what we choose to know? Or are we just seeing patterns and probabilities? But for most of us, the feeling is what matters. That gentle idea that even in a world ruled by rules, there's still room for softness, for change, for second chances. And maybe that's the quiet lesson, that not everything has to be known to be beautiful. Not every truth has to be captured. Sometimes, erasing a fact isn't a loss. It's a gift. A way to bring back what was lost. A way to let mystery breathe again. If this idea sparked something in your mind or heart, please like this video. Share your thoughts in the comments. Has forgetting ever helped you heal or see something in a new way? We'd love to hear your story. And don't forget to subscribe if you enjoy these quiet walks through strange and beautiful thoughts. Thank you for being here. For listening with soft ears. May you always find peace, not just in answers, but in the gentle power of forgetting. Contextuality effect. Have you ever noticed how the way someone talks to you can change depending on who else is in the room? Maybe your friend acts differently when they're around certain people. Or you behave differently in class than you do at home. It's still you, but somehow the way you speak, the choices you make, even how you feel, all shift depending on what's around you. The setting changes the story. The context shapes the outcome. Have you experienced that too? A moment where your response felt like it was guided by what else was going on around you? Let us know in the comments and tell us where in the world you're watching from. We love hearing from our quiet, thoughtful little community. Now, imagine this same idea, but not with people, with particles, with tiny pieces of matter so small they seem almost like whispers of reality. There's something in physics called the contextuality effect. It's a strange and beautiful idea. It says that the result you get from measuring a particle doesn't just depend on the particle itself. It depends on what else you're measuring at the same time. Change the questions and you change the answers. Not because the particle was different, but because the context was. To make this easier to imagine, think of a student taking a test. If you ask one question at a time, you'll get one kind of answer. But if you ask two questions together, something changes. The second question might change how they think about the first. The presence of one thought shifts the shape of the other. It's not about tricking the student. It's about how the mind works in connection with itself and with what surrounds it. Particles, it seems, may behave the same way. They don't hold a set answer inside them, waiting to be found. Instead, what they decide to show depends on the full setup, the complete picture of what's being asked. It's as if the particle is saying, "Tell me what kind of world you're creating around me, and I'll show you who I am in that world." That's already a soft and mind-bending idea, but when you take a step back, it starts to feel even more familiar. Because humans aren't that different. Think about how we act in relationships. Sometimes we say one thing and later something else, not because we're lying, but because the context changed. You're not the same person when you're alone, or when you're with your family, or when you're with strangers. Your behavior, your emotions, even your sense of right and wrong, can shift gently depending on the situation around you. The contextuality effect reminds us that truth is not always a single frozen point. It can be more like a shape that bends, with the light, with the company, with the mood. This doesn't mean that nothing is real. It just means that what is real can depend on how you look, and what else you look at alongside it. This also touches how we think about choices. In life, decisions don't happen in a vacuum. Whether it's choosing a job, solving a problem, or talking through a disagreement, the outcome isn't just about the facts. It's about the context, what you feel, what's happening around you, what your mind is holding in the background. In this way, the science of particles becomes a soft mirror for the science of being alive. Even in mental health, this idea finds a place. Some days we feel okay. Other days, the same events feel too much. The context, maybe lack of sleep, A long week or just a small comment can shift everything. There is no one answer locked inside us. We respond to the whole situation, just like a particle, reacting to the full picture. In the world of artificial intelligence, this effect has lessons too. When AI systems make decisions, they do so based on all the data they're given. If the input changes, the result changes, even if the question seems the same. It's a reminder that even machines are shaped by context. And maybe so is everything else. If this gentle paradox stirred something inside you, please like this video and share your thoughts in the comments. Do you feel like your actions or feelings shift depending on who or what is around you? We'd love to hear your stories. And if these soft and thoughtful journeys help you fall asleep or make you think a little differently, don't forget to subscribe. There's always more wonder waiting just beyond the next thought. Thank you for being here with us. May you find peace not just in solid answers, but in the gentle spaces in between, where context becomes meaning, and even the smallest things shift with care. Retrocausal signals. Have you ever made a choice and then thought, strangely, that maybe everything before it somehow led to that exact moment? Or even more puzzling, what if the choice you made now had already shaped what came before? It sounds impossible, doesn't it? Like something only a dream could imagine. But deep within the world of tiny particles, some scientists are starting to wonder, what if time doesn't always move the way we think it does? Let's take a moment to pause and reflect. Has something ever happened in your life that made you question time itself? A coincidence too strange to explain? A feeling that something had already happened, even though it hadn't yet? If you've ever felt that way, share your story, or just your location, in the comments. It's comforting to know we're all puzzling through these little mysteries, together. Now let's go gently into one of the most unusual ideas in modern physics, retrocausality. At its heart, it whispers this strange suggestion that actions in the present may, in very small and quiet ways, ripple backward in time. Not in a way that changes history or lets someone go back and redo their day, but in a tiny, delicate way, like a whisper in reverse. To make sense of this, imagine a teacher grading a test. Normally the answers are written first, and the grades come after. But what if, in some strange world, the grade you decide to give the test also affected how the student had written the answers in the first place? It doesn't make sense in the usual way. But on the level of particles, so small they can barely be said to exist in the way we understand, something like this might be happening. In a few unusual experiments, particles have shown patterns that suggest their earlier behavior could be influenced by measurements made after the fact. It's not that we're reaching back and changing the past. It's more that the future and the past may be deeply connected in ways we don't yet understand. Like two ends of a string pulling toward each other, no matter which one you tug. This thought has soft and strange echoes in our lives too. Sometimes we don't understand a moment until later, when something happens that changes the way we see what came before. A breakup that makes an earlier silence make sense. A job we didn't get that helps us understand what we really wanted. The future reshapes the past in our minds, even if the events stay the same. Retrocausality in this way mirrors memory and meaning. It's not about going backward. It's about how time may not be as one-directional as we think. Just like how you can reread a book and notice something new, something that had always been there but only now becomes clear. In relationships, too, we sometimes reinterpret things later on. A kind word from a friend might seem ordinary, until a difficult day reveals just how deeply it mattered. That moment, once forgotten, suddenly glows in your memory. The future, in a quiet way, reshaped your past. This is not just a scientific idea. It's a human one. That time may not be as sharp or clean as we draw it. Those feelings can float in both directions. That understanding can flow from what happens now to what we once thought we knew. Even in artificial intelligence, this plays out. When an AI learns, it constantly updates how it understands past data based on what it discovers later. It reprocesses everything from the start with new insight. The future, in a way, rewrites the past, not in facts, but in meaning. Retrocausal signals may not be something we see with our eyes or feel with our hands, but if they exist, they remind us of something gentle and deep. That time might be more like a circle than a line, that every moment is woven into every other, and that the story we're living may not just be moving forward, but breathing in both directions at once. If this idea touched something in you, whether a memory, a dream, or just a quiet sense of wonder, please like the video and let us know you're here. Tell us where you're watching from or share a moment where time felt like it blurred. And if these stories help you relax, sleep, or simply see the world a little differently, consider subscribing. We'll keep sharing gentle thoughts for curious minds like yours. Thank you for joining us. In this moment now, just as you are part of something timeless, objective collapse. Have you ever walked into a quiet room and felt like something had just happened? Something invisible but real? Like the air had changed, even though nothing seemed different? Sometimes it feels as if the world makes decisions on its own, not because of what we do, but because of something deeper, something built into reality itself. Let's start with a gentle question. Have you ever had a moment where it felt like life took a turn, not because of your actions, but almost like it was already written that way? Maybe the timing of a phone call, the way someone arrived just when you needed them, or a decision that seemed to make itself. If you've had one of those strange moments, share it in the comments, or let us know where in the world you're watching from. These quiet mysteries connect us across time and distance. Now let's take a breath and step into one of the most puzzling ideas in quantum physics, the thought that maybe the universe doesn't always wait for us to observe it. Maybe it makes its own choices. This is what's called objective collapse. It's the idea that the strange, ghost-like state of quantum particles, called superposition, doesn't just end when we look at them. Sometimes it ends all on its own, like a dream deciding when to become real. To understand this better, picture flipping a coin. While it's in the air, it hasn't landed yet. It's spinning, neither heads nor tails. But with quantum particles, the coin isn't just flipping, it's actually both heads and tails at the same time. That's superposition, a state where a particle is doing many things at once. But the moment we check, the moment we look, the particle chooses one outcome. It's like the coin suddenly deciding to be heads, just because you peeked. But here's the strange twist. Some scientists believe the particle doesn't need you to look. They think nature itself may set its own rules about when this ghostly state should end, that the universe might have its own quiet clock ticking in the background, deciding when a possibility must become a fact. This is objective collapse, a theory where the world shapes itself, whether or not you're watching. Think about the weather for a moment. Sometimes it seems random. The sky can change from sunshine to storms in minutes. But beneath that, there are patterns, pressures, winds, moisture. The storm doesn't wait for you to open your umbrella. It comes because of something much older and deeper than your presence. Maybe the quantum world is like that too. Maybe it doesn't need our eyes to unfold. Maybe it collapses when it's ready. This touches something very human, the feeling that we're not always in control, that some things happen simply because they must, like growing older, like falling in love, like forgetting something that once felt important. These changes come not with a sound, but with a quiet certainty, and sometimes we only notice them after they've happened. In relationships, you might feel this too. A shift in someone's tone, a moment when a connection fades, not because of a single word or action, but because something unspoken passed between you. You didn't collapse the moment, it collapsed itself, like a page turning when it's ready, not when you touch it. Even in technology, there are echoes of this idea. When an AI system trains itself on data, it doesn't always wait for direct instruction. Patterns emerge by themselves. The system learns not just from what it's told, but from the structure of what's around it. It collapses uncertainty into understanding automatically and sometimes unexpectedly. In language, too, we can feel this mystery. A sentence starts with one meaning, and by the time you reach the end, something has shifted. The tone, the context, the pause between words, meaning collapses into place on its own. Not forced, not pushed, just ready. So if the universe has its own timing, its own quiet way of shaping events, what does that say about us? Maybe we're not the only ones making decisions. Maybe some things decide themselves. And maybe that's okay, because in a world where everything is uncertain, there's something comforting in knowing that some choices aren't ours to make. They simply happen, and we meet them when we're ready. If this idea gave you something to think about, something gentle and strange, please like the video. If you'd like to hear more thoughts like this, subscribe and join us again. And if something about today's story reminded you of your own quiet moment of change, feel free to share it in the comments. We're all part of this strange, unfolding story, each one of us, a quiet observer in a universe that sometimes writes itself. Macroscopic superposition. Have you ever wondered what it would be like if the strange rules of the tiny quantum world, where particles can be in two places at once, applied to something as big as a car, or even a person? Imagine walking through your house, and at the same time your reflection in the mirror is both facing you and turned the other way. It sounds like something out of a science fiction story, doesn't it? But in the world of quantum physics, this isn't as impossible as it seems. If you've ever had one of those moments where everything just felt off, when reality itself seemed to blur or shimmer around you, then you might start to understand the unsettling feeling of what we call macroscopic superposition. It's a strange and fascinating concept. But before we dive into the heart of it, take a moment to think about your own experiences. Have you ever had a day where the weather felt unpredictable, shifting from sun to rain in a matter of minutes? Or perhaps you've had moments in life when things seem to be in two conflicting states at once, like trying to move forward in a decision but feeling stuck in place at the same time. These kinds of contradictions are common in human life, and they offer a glimpse into the quantum world, where reality itself can appear to be uncertain and strange. Quantum mechanics has long taught us that at the smallest scales, like with atoms and subatomic particles, things don't behave the way we expect. Particles can be in multiple places at the same time or spin in two opposite directions, all depending on how we look at them. But what happens when we try to stretch this bizarre behavior into the larger world around us? What if we took this quantum weirdness and tried to apply it to bigger objects, the kind of things we see and touch every day? This is where macroscopic superposition comes in. It's the idea that, under the right conditions, even larger objects might behave, like quantum particles. Imagine a cat in a box, alive and dead at the same time. This is the famous Schrödinger's cat thought experiment. But what if we could actually make that happen with something real? Imagine a real object, say a spinning wheel or a car, that can exist in two places at once, like the way particles can. If we could somehow push quantum behavior to these bigger scales, everything we know about how the world works would suddenly feel shaky. Think about it. If you were walking through a forest and suddenly the trees seemed to shimmer between two forms, one solid, one fuzzy, like they were both real and not real at the same time, how would you react? It would be unnerving. The very foundation of your reality would feel uncertain. The world around you would be split between the normal and the strange. But in quantum mechanics, this is exactly what happens. The rules we take for granted in our everyday lives, things being in one place, objects behaving predictably, would no longer apply. And that can be a difficult thing to wrap our heads around. Now, let's think about how this relates to our own lives. We live in a world where things are mostly clear. If I hold a cup of tea, I know it's there. If I walk into a room, I expect the furniture to be where I left it. But life is also full of moments when things don't make sense. When your plans fall apart or you feel torn between two choices, the world seems to lose its usual certainty. The idea of macroscopic superposition brings this feeling of unease into a whole new light. It suggests that, in some ways, the certainty we take for granted might just be an illusion, and that uncertainty could be waiting to stretch into every corner of our world. This idea reaches beyond just physics. It touches on our beliefs, our mental health, and even the way we interact with technology. Just as a quantum particle can exist in two places at once, we sometimes find ourselves torn between two versions of reality. Perhaps you've felt like you're stuck between two choices, unable to move forward. Or maybe you've experienced the feeling of being pulled in two directions by your thoughts or emotions. It's a common part of the human experience, feeling like you're both here and somewhere else, caught between different possibilities. The same thing happens in the digital world. Think about how technology has changed the way we experience reality. We can be in one place physically, but mentally we can be in a completely different space, like a conversation happening through a screen. Our virtual selves and physical selves sometimes feel disconnected, like they're existing in two worlds at once. AI, for instance, can perform actions and make decisions without us fully understanding how it works, creating a sense of uncertainty about where control lies. It's as if technology, like the quantum world, stretches the rules of what's possible. So, if macroscopic superposition were to become a reality, what would that mean for us? How would we navigate a world where things could be in two places at once, where the ordinary rules of nature didn't apply? Would we embrace the uncertainty, or would we find it unsettling? The truth is, we're already living in a world that sometimes feels like it's pushing the boundaries of what we understand. Whether it's the unpredictable weather, the uncertain paths we take in life, or the strange behavior of quantum particles, we're all familiar with the feeling that things are not always as they seem. If today's video made you pause and reflect on the strange ways the world works, please give it a thumbs up. If you enjoy exploring these mysteries with us, consider subscribing for more thought-provoking content. And if you've ever felt like reality itself was stretching and shifting around you, or if you've had one of those moments where everything just didn't make sense, share your thoughts in the comments below. We'd love to hear from you and connect with you as we continue exploring the wonders and mysteries of the universe together. Decoherence, barrier. Have you ever watched something vanish into thin air? Perhaps it was the sudden disappearance of a bus you were waiting for, or that moment when a cloud seems to melt into the sky, leaving nothing behind. These moments can feel strange, almost as if reality itself decided to blur for a while. Now imagine a world where everything is like that, where the tiniest things, like particles, can be in two places at once, or act in ways that make no sense to us. This might sound like science fiction, but in the realm of quantum mechanics, particles do just that. They exist in a strange world of possibilities. But here's the catch. The more we observe, the more we start to see the normal, predictable world we know. Why does this happen? What causes all this weirdness to fade, turning into plain old reality? This phenomenon is known as the decoherence barrier. It's a fascinating concept in quantum physics that helps explain why the strange behavior of particles doesn't continue into our everyday lives. You might think that everything around us should be just as strange as quantum particles. But there's a reason why we don't walk through walls or appear in two places at once. The decoherence barrier explains how the weirdness of quantum mechanics gets blurred when it interacts with the world around it. The result is that the chaos of possibilities becomes the clear, solid reality that we experience. Think about it this way. Imagine you're holding a glass of water. As you move it through the air, the world around the glass, like the air, the light, and even the temperature, all interact with it. The water stays in the glass, and the air doesn't bend in strange ways. But what if, for a moment, you could see the water as a quantum particle? It might be both inside and outside the glass at the same time. However, as soon as the glass is observed, the weird possibilities disappear, and it becomes just the water we know. This shift from strange to normal is the decoherence barrier in action. It's a bit like a fog. When you're far away from it, you can see the haze that's unpredictable and confusing. But as you get closer, the fog clears and everything sharpens into focus. The decoherence barrier is the point where the strange quantum possibilities clear up into the solid, predictable world we see. The strange particles that can be in two places at once are gradually forced to make up their mind and pick one place, the moment they are observed or interact with something else. Just like how the fog fades away when you walk into it, the quantum weirdness is replaced by the reality we are used to. Have you ever had moments when things felt fuzzy or uncertain? Maybe there was a day when your thoughts seemed all over the place, where you weren't sure if you should take one path or another. It's like standing at a crossroads, unsure whether to choose one way or another. And in that hesitation, everything feels like it could go any direction. In many ways, that's what quantum particles experience until they are observed. The possibilities stretch out in front of them, but they only pick one when we look at them. It's the uncertainty of potential becoming the clarity of reality. This idea of decoherence connects to larger questions about the nature of reality and the role we play in shaping it. For centuries, philosophers and scientists have pondered whether our perception of the world creates the world itself. Is reality just the result of our observations? Are we somehow shaping it just by being part of it? In quantum physics, it almost seems like the act of observing or interacting with something causes it to choose a path, blurring all other possibilities. This is the decoherence barrier, the point at which everything shifts from quantum weirdness into the clear world we recognize. In our everyday lives, we often experience something similar to decoherence. Think about the feeling of being torn between two choices. When you're unsure, the possibilities feel wide open, and nothing seems clear. But the moment you make a decision, the many possibilities collapse into one reality. Your future path becomes clear. It's like how quantum particles have to settle into one state when they are observed. Until then, everything feels open to interpretation. And what about the times when you find yourself thinking about a choice long after it's made? The decision might be done, but the lingering feeling of uncertainty sticks around. This is a bit like how quantum systems don't fully collapse until they interact with the outside world. In the same way, the world around us can sometimes leave us with lingering doubts even after we've made a choice. The decoherence barrier also raises questions about our interaction with technology. Consider AI systems that make decisions for us. We give the system a task, and it takes care of everything without us needing to observe every step. In a way, it's as though the system's quantum potential, the many ways it could behave, becomes clearer and more predictable when we interact with it. This mirrors how decoherence works. Once a system is observed or measured, its potential states become fixed and its behavior becomes predictable. Imagine if instead of interacting with technology in a clear, controlled way, we had to deal with it in its full quantum state, where everything is uncertain and the possibilities are endless. It would be overwhelming. But just like with quantum particles, our interactions with the technology collapse it into something understandable. This is the decoherence barrier at work, as it helps transform the weird, uncertain world into something we can manage and comprehend. So as you go about your day, remember that the world you experience, the solid, predictable one, might not be as certain as it seems. Much like the quantum particles that lose their strange potential when observed, our reality might only be one of many possibilities until we look at it. Every time we observe, interact, or make a decision, we're taking a small step through the decoherence barrier, turning the endless potential into one fixed, clear reality. If you've enjoyed exploring this fascinating idea, don't forget to give this video a like. We'd love to hear your thoughts in the comments. Have you ever experienced a moment where the world around you seemed to blur, only to snap back into focus? Please share your experiences, and remember to subscribe for more thought-provoking content as we continue to explore the mysteries of the universe together. Quantum gravity clash. What if the very laws that govern the universe can't quite agree with each other? Imagine being at a crossroads where two roads seem to lead in opposite directions, yet both appear to be essential for your journey. This paradox is at the heart of one of the most mysterious challenges in modern science: the clash between gravity and quantum mechanics. On one hand, gravity pulls everything together, It's the force that keeps us grounded on Earth and governs the motions of galaxies. On the other, quantum mechanics governs the tiny, unseen world of particles, where strange things happen that don't seem to obey the usual rules of physics. Now, imagine trying to combine these two powerful forces into one theory that explains everything. It doesn't quite work. Gravity and quantum mechanics don't seem to get along, and the more we try to bring them together, the more we realize that something deeper must be at play, something we're still struggling to understand. We experience gravity every day. It's the reason we stay on the ground, why rain falls, and why things drop when we let go of them. It's a force that's simple to observe, but surprisingly complex to understand. According to Isaac Newton, gravity is the force that attracts objects with mass toward each other. It's predictable and consistent. However, when we zoom in on the tiniest parts of matter, the rules change. In the quantum world, particles behave in bizarre and unpredictable ways. They can be in two places at once. They can teleport from one location to another, and they can even be linked across vast distances. These are the strange behaviors that quantum mechanics describes, and they work perfectly well on a small scale. But here's where the problem arises. Gravity does not fit neatly into this quantum world. In fact, the theory that describes gravity, known as general relativity, works extremely well on large scales, such as planets, stars, and galaxies. It explains how the massive forces of gravity shape the universe, pulling objects like the Earth into orbit around the Sun. However, this theory doesn't work at all when it comes to the tiny particles that quantum mechanics deals with. It's as if gravity and quantum mechanics are playing two separate games, with no common rules, no overlap, and no way of reconciling them. Think of it like this. You're walking in a field and you come across two streams. One stream is calm, slow-moving, and easy to follow. It's gravity. The other stream is wild and fast, rushing around in every direction. It's quantum mechanics. Now, imagine trying to combine the two streams into one river. No matter how you try, they just don't mix. The calm and predictable flow of gravity struggles to blend with the chaotic and uncertain flow of quantum mechanics. This struggle is at the core of the quantum gravity clash. You might be wondering, why does this matter? Well, this clash between gravity and quantum mechanics suggests that there's something we don't yet understand about the universe. Maybe there's a deeper, hidden layer of reality where these two forces come together in harmony. Scientists have been trying for decades to find this theory of everything, a single theory that unites the fundamental forces of nature. But so far, gravity and quantum mechanics have refused to fit together into one complete picture. It's like looking at two puzzles that, on the surface, seem to belong to the same set. They have similar colors, the same number of pieces, but the pieces don't fit. The solution, it seems, is not just a matter of rearranging the pieces, it's about finding the right pieces that belong together. Perhaps there's a deeper principle we haven't discovered yet, something that could bridge the gap between gravity and quantum mechanics. This paradox touches on bigger questions too. What do we really know about the universe? Our everyday experiences are shaped by gravity, and the tiny details of the world are governed by quantum mechanics. But what if the reality we know is only part of a much bigger, more complicated picture? This could change how we think about the universe, about the very fabric of reality. It challenges our understanding of time, space, and the forces that govern them. Could our perception of the universe be incomplete? Perhaps our minds, shaped by centuries of experience, are limited in their ability to comprehend these deeper truths. This is the heart of the quantum gravity clash. It suggests that there may be layers of reality we have yet to peel back. This paradox is also a mirror for our own lives. In many ways, we all experience clashing forces, desires, responsibilities, hopes, and fears. These forces can often feel like they don't fit together. We find ourselves torn between different paths, struggling to reconcile conflicting desires, ideas, or goals. Just as gravity and quantum mechanics refuse to be reconciled in the same theory, we too may find ourselves struggling with opposing forces that don't seem to match up. This tension is part of what makes life mysterious and challenging. In the realm of artificial intelligence, these clashing forces are mirrored in the way technology is shaping our world. AI systems are designed to follow rules, to predict and act based on data. But there's an unpredictability to human behavior, to the way our emotions and thoughts don't always follow logic. As we develop AI systems, we must figure out how to navigate the tension between predictability and chaos, just as scientists struggle to understand how gravity and quantum mechanics can coexist. Before we dive deeper into this complex topic, I'd love to hear your thoughts. Have you ever encountered a situation where two forces in your life just didn't seem to fit together? Maybe you've been torn between two choices, both important but impossible to reconcile. Share your thoughts with us in the comments below. Let's explore this paradox together. And if you enjoy diving into the mysteries of the universe, don't forget to like, subscribe, and join us for more discussions that unravel the strange and wonderful truths about our world. Transactional waves. What if the past and future were somehow connected, not just by memory or prediction, but by a deeper, mysterious exchange? Imagine you're planning to meet a friend. You send a message confirming the time and place, and they reply to confirm the same. In our everyday world, we think of time as a one-way street. What's ahead is unknown, and what's behind us is fixed. But what if particles, those tiny building blocks of the universe, were doing something even more unusual? What if they were sending out offers to the future and getting confirmations from the past? This paradox is like a handshake across time, where particles make deals with themselves, and those deals are sealed with messages sent in both directions. At first glance, this idea seems impossible. After all, we know time only flows in one direction for us. We can't go back and change the past. And yet, in the strange world of quantum physics, things don't always behave as we expect. Particles, those tiny specks of matter that make up everything around us, don't just sit still and follow simple rules. Instead, they act in ways that challenge our understanding of reality. One of the most puzzling aspects of quantum mechanics is that particles don't have fixed positions until they're measured. Instead, they exist in a kind of cloud of possibilities, where they could be anywhere and everywhere at once. This might sound strange, but it's a phenomenon known as superposition. Now imagine that these particles aren't just existing in multiple possibilities at the same time. They're also communicating across time. In this scenario, particles don't only make decisions about their future, they send out offers to what will come, while simultaneously receiving confirmation from the past. This interaction might sound like science fiction, but it's an idea that some quantum theories suggest: that waves, the core of how particles move, don't just travel forward in time, they also extend backward. This transactional exchange between past and future could be key to understanding how particles behave, and it could even be a fundamental part of how the universe works. Think about how we make decisions in our own lives. We don't usually think of the future and the past interacting with each other, but we do have a sense of influence from both directions. For example, a decision we make today might be influenced by a memory from the past or a goal we have for the future. These offers and confirmations shape the choices we make, even though we're not aware of them. Similarly, particles could be interacting with both the future and the past in ways that influence their behavior in the present. This creates a loop, a kind of quantum handshake that allows the universe to negotiate its path across time. The present moment, it seems, is not just shaped by what has already happened. It's also shaped by what is yet to come. This idea can be hard to wrap your head around, but it's a bit like making a decision in life and then realizing later on that it was the best choice. It feels as if the future gave you a confirmation of your decision, even though you made it without knowing exactly what was coming. This type of feedback loop, where future and past influence each other, is what we might see happening at the quantum level. This paradox isn't just about particles, it's also about how we experience time. It challenges the way we think about the world around us. We've all heard that time is linear, that it moves from past to present to future. Yet, in the quantum world, it's as if time isn't so strict. Just as we experience time through our memories and dreams of the future, Particles might also experience a kind of fluidity, where the lines between past, present, and future aren't as sharp as they seem. There's also a broader theme here, the way our minds work. Our thoughts often jump between the past and the future. We reflect on what has happened, we plan for what might come, and we adjust our present actions accordingly. This paradox reminds us that perhaps our own understanding of time, of how we live in the world, is more flexible than we realize. Our thoughts are constantly shifting across time, much like particles might do in the quantum world. It's as though we're all part of a larger cosmic dance, where the past and future are in constant dialogue, influencing our present decisions, actions, and reactions. When we look at this paradox through the lens of artificial intelligence, it presents an intriguing challenge. AI systems are designed to predict the future based on past data, but they don't typically account for any backward influence. What if in the future, AI could learn to incorporate these backward signals, messages from the past that shape decisions in the present? This kind of AI might work more like how we think and make decisions, constantly adjusting based on both what has happened and what is yet to come. This paradox also touches on a deeper philosophical question. What role does our perception of time play in how we shape reality? If time is not as linear as we thought, then does that mean our understanding of cause and effect is incomplete? The transactional nature of quantum waves suggests that the universe might be more interconnected and complex than we can fully grasp. It raises the possibility that we are, in fact, influencing our own future and past in ways that we don't fully understand. Before we explore this strange concept further, I'd love to hear from you. Have you ever had an experience where the past seemed to confirm a decision you made for the future, or where you felt as though your future self was guiding you? Share your thoughts in the comments below. And if you find this journey into the unknown as fascinating as I do, be sure to like, subscribe, and join us for more explorations into the mysteries of the universe. Pilot wave hypothesis. What if the particles that make up everything around us aren't just floating aimlessly, following random paths? What if they were guided by unseen forces, like an invisible hand, gently steering them along a specific course? This idea may sound a little strange, yet it's an intriguing concept in quantum mechanics known as the pilot wave hypothesis. It suggests that there might be hidden waves that guide particles in ways we can't directly see, but their influence shapes the world around us in powerful and mysterious ways. Imagine you're walking through a dense fog. You can't see everything clearly, but the fog still influences your path. In a way, the particles in this hypothesis are like that. They're not alone, but are guided by something we can't immediately perceive, an unseen hand that helps shape their journey through the quantum world. This idea might seem strange because in our everyday lives we think of particles as being independent, moving in straight lines or bouncing off things. But in the quantum world, particles behave very differently. They don't always follow clear-cut paths. Instead, they seem to act unpredictably, as if they're in more than one place at once, following multiple potential paths before settling on one. This strange behavior is known as superposition, and it has puzzled scientists for years. The pilot wave hypothesis offers a different explanation for this behavior. Instead of seeing particles as free agents, the hypothesis proposes that they are actually guided by an invisible wave, which helps direct their movement. It's almost as though the particle is being gently pushed, nudged, or led along a path by something we can't quite see. Let's bring this idea into something more familiar. Say driving a car. Imagine you're behind the wheel of a car in thick fog. You can't see the road very clearly, but there's something guiding you forward. Whether it's the feel of the steering wheel, the sounds around you, or subtle clues you pick up. You're not making decisions from scratch, but responding to the invisible forces around you. This might be a good way to think about the pilot wave hypothesis. The particles might not be acting on their own. Instead, they're responding to the invisible waves that steer them, just like the car responds to the environment in the fog. The waves act like a kind of roadmap, guiding the particles along their course, even though we can't always directly observe them. This idea has deep implications for our understanding of the universe. In our everyday world, we see things moving in predictable ways. We throw a ball, it falls to the ground, we kick it, it moves. These actions follow the simple rules of cause and effect. But in the quantum world, the rules aren't so clear. Particles don't always behave predictably. They seem to be in many places at once, and their paths appear to be shaped by hidden forces. The pilot wave hypothesis suggests that these hidden forces are waves that guide the particles, giving them direction even when it seems like they're just randomly bouncing around. This hidden guidance gives rise to the idea that the universe might be more ordered than it appears on the surface. It's almost as if there's an invisible hand behind the scenes, making sure everything stays on track. The pilot wave hypothesis also invites us to reconsider our understanding of reality. If we imagine that there are hidden forces guiding us through life, it's not hard to see parallels in our own experiences. Many of us feel that our actions are influenced by things we can't always explain. Our gut feelings, our instincts, or even those small nudges we get from the world around us. These invisible forces shape our decisions, often without us even realizing it. In this sense, the pilot wave hypothesis might not be so different from how we experience the world. Just as the particles are guided by waves they can't see, we are often guided by forces beyond our immediate understanding. These influences shape our actions, our choices, and even the course of our lives. There's also a bigger theme at play here, the question of control and influence. In life, we often feel like we're in control of our own destiny. We make choices, take action, and try to steer our own paths. But sometimes it feels like there are forces beyond our control that influence the direction of our lives. These could be external influences, like relationships, circumstances, or even the environment we find ourselves in. The pilot wave hypothesis suggests that the particles, too, might not be as free to choose their paths as we think. They are guided by something beyond themselves, just as we may be guided by forces outside of our direct control. Thinking about this in the context of technology and artificial intelligence, AI, is fascinating. Imagine AI systems that rely on guidance and influence beyond their programming. Could there be a way for AI to act in ways that aren't fully predictable, like particles guided by hidden waves? Could they make decisions based on subtle, unseen influences that help steer their actions, even though we can't directly observe them? This idea of hidden guidance could change the way we think about AI, making it feel more intuitive and less mechanical. Instead of acting only according to programmed rules, AI might one day be influenced by forces we can't entirely explain, much like particles in the quantum world. As we reflect on the pilot wave hypothesis, we're reminded that the universe is full of mysteries. It's easy to think we understand everything around us, but ideas like this show us just how much there is yet to learn. Perhaps the most profound insight we can take away from this concept is that, just as the particles in the quantum world are not alone, we too are not alone in our experiences. We are all guided, influenced, and shaped by invisible forces that help steer us along our paths. Whether we see it or not, we are part of a larger system. Just like the particles, we are moving through the world with a gentle, unseen guidance. I'd love to hear your thoughts on this. Have you ever felt that invisible guidance in your own life, something nudging you along your journey? Share your experiences with me in the comments below. And if you enjoyed this exploration into the hidden forces that shape our world, be sure to like, subscribe, and join us for more thought-provoking discussions. Let's keep uncovering the mysteries together. Many worlds split. What if every choice you made, no matter how small, created a whole new world, a new version of reality? Imagine that every time you decide to turn left instead of right, or pick one job over another, an entirely new universe is born, each branching out from the last. This might sound like a plot straight out of a science fiction story, but it's a concept taken seriously by some scientists. It's called the many worlds interpretation of quantum mechanics, and it suggests that every decision, every moment, might lead to the creation of a new universe, like a giant tree, growing with each choice we make. Picture a simple decision, like what to have for breakfast. Maybe today you choose cereal, and in a parallel universe you decide on toast. In both worlds, everything continues from there. Your day unfolds in one direction or another, but in both, your existence continues. And it's not just big life-changing choices that create new worlds. Even the smallest decisions could split reality. That casual yes or no you say today might be the moment that sparks the birth of an entirely new reality. A different world where things could turn out completely differently. Let's make this even clearer. Think about the weather. When it's cloudy, we might decide to take an umbrella with us, but on other days, when the sun shines bright, we leave it behind. In one world, the umbrella shields us from a sudden downpour. In another, we walk through the sunshine, dry and happy. Both outcomes are real, but they exist in separate worlds. Now, imagine this on a much larger scale. Every moment you experience could be the result of infinite possible outcomes, each one unfolding in its own separate universe. It's almost like there's an endless library of realities, and each decision you make opens a new book in that library. You might be wondering, what does this all really mean for us? For starters, it challenges our understanding of choice, destiny, and the nature of our own existence. If every possible version of reality exists somewhere, then what does it mean? For our decisions, do we still have control over our lives, or is it just a matter of which branch of the tree we happen to be on? Does it matter which choice we make when there are infinite other versions of us out there, each living a different outcome? This idea can also change the way we think about regret. If you've ever wished you'd chosen differently or wondered about the path you didn't take, the many worlds interpretation gives us a comforting thought. In another universe, you might have made a different choice, and maybe that version of you is happy, just like the version of you in this world. In that sense, there's no real wrong choice, because all possible versions of you are living out their own unique story. Regret might just be an illusion, a feeling that doesn't exist in the broader scope of the infinite possibilities available to us. Now, think about it in terms of our beliefs, mental health, and how we see ourselves. The idea that every choice leads to a new reality could help us see that life is full of possibilities, each one just waiting to be explored. The belief that our choices are final and unchangeable can sometimes make us feel trapped, or that we've missed out on something important. But what if that's not true? What if every path we could take exists in another universe, just waiting for us to step into it? This could change the way we think about our struggles. If we face a difficult decision or feel stuck, we might remind ourselves that in another reality, a version of us has already chosen a different path and is doing just fine. It brings a sense of peace, knowing that no matter what, all paths lead to something real, and there's no such thing as a truly wrong decision. On a larger scale, the many worlds theory touches on how we understand language, communication, and even our very concept of reality. If every choice creates a new universe, then language itself could be a reflection of these endless possibilities. Every time we speak, we open up countless directions, each sentence leading to a new chain of events, each conversation branching off into new realities. Our interactions with others become more than just exchanges of information. They're opportunities to create and shape the world around us, not just in this moment, but in all the possible versions of our existence. You might also be wondering how this idea connects with artificial intelligence, AI, and technology. Could AI be part of this branching tree? In some ways, AI already creates multiple paths, just like we do with every decision we make. Each time AI makes a choice, even a simple one, it opens up a new possibility, a new outcome. In the future, as AI continues to evolve, it might even be able to simulate the many worlds theory, offering us a glimpse of what could happen in all possible scenarios. This could completely transform the way we think about technology, giving us a deeper understanding of choice, consequence, and the endless possibilities available in the digital world. If you've ever found yourself wondering what might have been if you'd chosen differently, the many worlds theory offers an intriguing possibility. Maybe, somewhere out there, another version of you made that choice and is living that different life. It's a comforting thought, reminding us that no matter what happens, every choice creates a new chapter in the book of life, and every path is worth exploring. The universe, it seems, is far bigger than we can imagine, and with each decision, we get to discover a new part of it. I'd love to know your thoughts on this. Have you ever wondered about the other paths you could have taken in life? How do you feel about the idea that every choice you make could create a new universe? Share your thoughts with me in the comments below, and if you enjoyed exploring this fascinating concept, don't forget to like, subscribe, and join me for more deep dives into the mysteries of existence. Energy-time uncertainty. Imagine this, a flicker of light, just a brief spark appearing out of nowhere, only to vanish just as quickly. It's so fleeting, so quick, that it almost feels like it never happened at all. What if I told you that this kind of event, something that seemingly defies the usual rules of how things work, could actually happen in the very fabric of the universe? In the world of quantum mechanics, energy blips can appear and disappear in the blink of an eye, as long as they vanish fast enough. This is the essence of the energy-time uncertainty principle. It sounds strange, almost like a magic trick, but it's rooted in the way the universe works at the smallest levels. Think of it like this. We know from experience that if you're trying to measure something, like the temperature outside or how long it takes to walk to the store, the more precisely you want to measure one thing, the less precisely you can measure something else. The same idea applies to energy and time in quantum mechanics. If you measure the energy of a system with great accuracy, you can't know the exact amount of time it exists with the same level of precision, and vice versa. The shorter the time, the greater the uncertainty in the energy, and within this uncertainty, strange things happen. Tiny bursts of energy can pop into existence, lasting just long enough to be noticed, but not long enough to be truly pinned down. You might have seen this in everyday life. Maybe you've been waiting for a bus, and for just a second you thought you saw a flash of light or a shimmer in the air, but when you looked again, it was gone. It wasn't your eyes playing tricks on you. It could be that, for that tiny moment, something truly ephemeral happened in the world around you. Something so quick it didn't last long enough to be detected properly. This same phenomenon happens all the time, but on a much smaller scale, where energy itself flickers into existence and disappears just as fast, never sticking around long enough to be measured. These tiny bursts of energy are more than just an oddity of nature. They can tell us something profound about how the universe works. They hint at a deeper mystery in the way everything is connected, a glimpse into the true nature of reality. The energy-time uncertainty principle suggests that reality is not as fixed and predictable as we often think. In our everyday lives, we assume that things exist in a steady, unchanging way. But in the quantum world, things are constantly shifting, flickering in and out of existence. Now, let's think about how this might relate to something more personal, like the way we experience time and energy in our own lives. Have you ever had a moment when you felt like you were living in a flash? Maybe you were deeply focused on a task or immersed in a conversation, and suddenly, it felt like the whole world slowed down, or maybe sped up. You were caught in that fleeting moment where everything seemed to vanish and reappear in an instant, like a spark of energy that was there 1 second and gone the next. We might not be able to measure it in scientific terms, but these kinds of experiences give us a tiny window into how the universe works. Moments when time seems to stretch or collapse. Moments when the usual rules don't apply, much like the energy blips of quantum mechanics. In terms of belief and philosophy, this paradox might challenge our understanding of time itself. If energy can appear and disappear in the blink of an eye, what does that say about the flow of time in our own lives? Is time as solid and constant as we believe, or is it just another wave of uncertainty where everything is in flux? These tiny bursts of energy suggest that the universe at its core is more fluid and unpredictable than we've been taught to think. And if this is true for the tiniest particles, might it also be true for our own experiences of time? The moments that feel like they last forever, or those that seem to fly by in the blink of an eye, might actually be more tied to the fundamental nature of the universe than we realize. As for the way this might connect to technology, especially AI, it's fascinating to think about how these brief moments of energy could have an impact on the development of machines. AI relies on energy and time to process information, and, even though it might not experience flickers in the same way humans do, it operates on a similar principle. By using a deep understanding of energy and time, AI might one day unlock new possibilities for us, showing us how to make the most of these fleeting moments and harness their power. Just as a quantum particle can burst into existence and vanish, perhaps AI can learn to handle these moments of rapid change, adapting to shifts in time and energy, and helping us make decisions in the midst of uncertainty. What does this mean for our mental health? Well, this principle reminds us that things don't always have to be permanent to be real. Just like those fleeting moments of energy that appear and disappear, our emotions, experiences, and even our struggles may not always last. We might feel overwhelmed by a problem, but in the grand scheme of things, the uncertainty of energy and time shows us that everything is temporary. These little bursts of energy in the quantum world can be a metaphor for how we can sometimes feel like everything is in constant motion, but with the right perspective, even the hardest moments can fade away, just like a flash of light. I'm curious to hear your thoughts on this. Have you ever had a moment where time seemed to disappear or stretch in a way that felt almost unreal? How do you think the idea of fleeting moments relates to the way we experience our lives and our choices? I'd love to hear your thoughts. If you found this exploration of the energy-time uncertainty principle interesting, please like, comment, and subscribe to stay tuned for more deep dives into the mysteries of the universe. Quantum Cheshire. Imagine a world where something could belong to you, but at the same time not be with you. It's like wearing a jacket on a chilly day, only for the warmth to seem to drift away from the fabric itself. You're left holding the jacket, but somehow the warmth is no longer inside it. It's a strange thought, isn't it? Now, let's make this even more puzzling. What if I told you that this isn't just a quirky idea, but something that could actually happen with the tiniest particles in the universe? In the quantum world, properties like spin, the direction a particle is spinning, can separate from the particle itself. This strange phenomenon is called the quantum Cheshire, and it's one of the most mind-bending aspects of quantum mechanics. It might sound like something from a science fiction story, but it's based on real scientific experiments. The quantum Cheshire paradox shows us that a particle can keep its identity while its properties, like spin, can float away and exist in a different location. Imagine for a moment that you could send your thoughts somewhere else while you remained standing still. It's a bit like you being here, but your thoughts are in a completely different place, entirely detached from you. In the quantum world, particles can do something similar, where their physical properties can exist away from them, almost as if they are separate entities. Let's break this down using something simple. Think about a spinning top. When you spin it, it spins with a certain direction, clockwise or counterclockwise. This direction of spin is like the property of the spinning top. In the classical world, this direction is tied directly to the top itself. If you watch the top spin, you can clearly see its direction. But in the quantum world, things get weird. Imagine that the spin of the top could somehow separate from the top itself, as though the spinning action continues without the top being the one responsible for it. It would be as if the top and the spin existed in two different places, completely disconnected. This paradox challenges our everyday experience of how things should behave. In our world, when you see a spinning top, you assume that its spin is tied to the top. We trust that what we see is directly connected to what is happening. But quantum mechanics introduces a different reality, where what we think is fixed and tied together can actually be split apart. The quantum Cheshire paradox teaches us that at the smallest scales, the universe operates in ways that don't always follow the rules we know. You might be wondering how this relates to our lives, right? Well, think of the ways we experience emotions and thoughts. Sometimes we can feel distant from our feelings, as though our emotions are separate from who we are. Imagine being upset about something, but not fully understanding why or feeling disconnected from the source of that emotion. It's almost like your feelings have become detached from you in a way that's hard to explain. This is similar to what happens in the quantum world, where properties of particles can drift away from the particle itself. Just as we can sometimes feel that our emotions or thoughts are not fully in sync with our experiences, particles in the quantum world experience a kind of separation between their properties and their physical selves. This idea also touches on the ways we think about identity. In everyday life, we often assume that who we are is inseparable from what we feel or what we do. Our actions, our thoughts, and our identity are tightly bound together. But the quantum Cheshire paradox suggests that identity is not always so clear-cut. Just as a particle's property can float away and exist separately, maybe, in our own lives, we can begin to separate different aspects of who we are. We are not simply the sum of our thoughts, feelings, or actions, but something more. This can be liberating in some ways. It suggests that we are not entirely defined by any one part of ourselves. The paradox reminds us that identity, whether on the quantum scale or in our personal lives, can be more fluid than we realize. This idea of separation also resonates with the world of artificial intelligence. AI systems operate based on a set of properties, programming, algorithms, and data processing. But could AI someday split its core functionality and its operational properties in a way similar to the quantum Cheshire? In the future, as AI becomes more advanced, it might have the ability to manipulate its own properties and functions independently. This could lead to even more sophisticated machines that think and act with a level of independence that feels almost disconnected from the code that created them. Thinking about this paradox also brings up questions about perception. In the world of quantum mechanics, what we observe may not always match what is truly happening. This touches on how we perceive reality in our own lives. Just as the properties of a particle can be separated from the particle itself, our perception of the world can sometimes seem disconnected from what is actually happening. This can make us question our own experiences. Are we seeing the full picture, or is there more happening behind the scenes that we're not aware of? Our minds create a reality based on what we can perceive, but perhaps reality itself is more fluid and less tied to what we observe than we think. I wonder if any of you have ever felt like your emotions, thoughts, or experiences didn't completely align with who you are. Have you ever had a moment when you felt distant from your feelings, as if something about you was somehow drifting away? If so, you've touched on the essence of what the quantum Cheshire paradox reveals, that things can be separate from their usual identity, even in our own lives. I'd love to hear your thoughts on this idea. Do you think there's a way we can apply this strange quantum concept to better understand ourselves or our world? Feel free to share your thoughts in the comments below. If this exploration into the mysteries of the quantum world intrigued you, don't forget to like, comment, and subscribe. We'll continue diving into the strange and fascinating wonders of the universe together. Co-conspector, have you ever tried to understand something so deeply only to find that the more you try to pin it down, the more it slips away? It's like trying to catch water in your hands. No matter how tightly you grasp, it seems to escape, leaving you with nothing but the feeling that something is just out of reach. In the realm of quantum mechanics, there's a principle called the co-conspector theorem that mirrors this elusive feeling. It tells us that you can't assign fixed values to certain traits of quantum particles without facing contradictions. Imagine trying to label a cloud with specific colors. It changes shape constantly, and no label can truly capture its essence. The co-conspector theorem suggests that quantum particles behave in a similar way. No matter how much we try to observe and define their traits, they seem to defy simple labels. Now, let's break this down with something familiar. Think of the weather. On a sunny day, it seems predictable. Clear skies, no clouds, just the warmth of the sun. But if you take a closer look, the weather isn't as simple as it appears. In a way, it's like trying to give a fixed value to something that's always shifting. Just as the weather can change from sunny to cloudy in a matter of minutes, quantum particles shift between different states, and it's impossible to pin down their exact traits all at once. For example, The spin of a quantum particle, which refers to its angular momentum, isn't something that can be easily defined. It's not like a simple direction like left or right. Instead, it's a property that can change depending on how you observe it. Trying to assign fixed values to this trait would be like saying the weather will always stay sunny or always stay cloudy. It doesn't work that way. This paradox, where traits cannot be fixed or pinned down without contradiction, also touches on something deeper. It challenges our very understanding of reality. In our everyday lives, we think about things in terms of certainty. We can see a tree and know that it's there, standing tall with leaves, bark, and branches. We can predict that it will grow and change over time, but we can understand its form and shape at any given moment. This certainty gives us a sense of security in our world. But quantum mechanics, and the Cauchy-Specker theorem in particular, flips this idea on its head. It suggests that, at the most fundamental level, the universe doesn't always work the way we expect. Things don't have fixed traits that are easy to measure or define. Instead, they exist in a kind of fluid state, where their characteristics are constantly shifting. Let's take this back to something we all experience: relationships. Have you ever found yourself trying to understand a person's behavior, trying to label them as kind or distant, generous or selfish? Often you'll find that the more you try to define them with fixed labels, the more complex and contradictory they become. People, much like quantum particles, are not static. Our moods, our actions, and our thoughts shift, making it nearly impossible to assign fixed traits to who we are at any given time. This is a natural part of human nature, yet it's something we tend to ignore or overlook. We want simplicity and certainty in our relationships, but life is far more complex than that. Just as you can't fix a quantum particle's spin with certainty, you can't always assign fixed traits to people without running into contradictions. This principle can also extend to how we perceive the world. Think about how we form beliefs. We try to understand the world and assign labels: good or bad, true or false, right or wrong. But these labels are often incomplete. Like a quantum particle, our understanding of the world is always shifting. Sometimes what we believe to be true today may change tomorrow as we gain more information or perspective. This constant flux challenges the idea that anything can be fixed or certain, and it's a reminder that life itself is full of contradictions. These contradictions are not weaknesses, but rather signals of the complexity and depth of the world around us. If we look at how the Cauchy-Specker theorem relates to mental health, the idea of fluctuating traits becomes even more profound. Just as quantum particles can't be fixed into a set value, our mental states and emotions are in a constant state of change. One moment, you might feel calm and at peace, but the next, anxiety or stress may appear. The paradox here is that we can never really define our mental state with total accuracy at any given moment. Our emotions shift, sometimes unpredictably, just like quantum particles. This concept can be both freeing and challenging. It reminds us that we are not bound by a fixed mental state, but it also encourages us to be more mindful and accepting of the fluid nature of our feelings. Now let's think about the role of AI and technology in all of this. Much like the shifting properties of quantum particles, AI and machine learning systems are not fixed. They constantly evolve, adapt, and change based on the data they receive. Just as the traits of a quantum particle can't be fixed without contradiction, AI systems can't be completely defined in a static way. They are in a constant state of flux, learning and adapting. This opens up a fascinating opportunity. What if AI could one day learn to embrace uncertainty, much like the quantum world, and become more adaptable to unpredictable changes in the environment? The idea of AI functioning in an uncertain, ever-shifting manner could lead to innovations we can't yet imagine. As we wrap up this deep dive into the Cauchy-Specker theorem, it's clear that the paradox of fixed values not being assignable to quantum traits challenges how we understand both the universe and ourselves. It suggests that things are never as simple as they seem, and that certainty might be an illusion. Just as we can't fix the spin of a quantum particle with complete certainty, we can't always define our own lives or the world around us with rigid labels. It's this uncertainty that makes life rich, complex, and full of surprises. I'd love to hear your thoughts on this. Have you ever encountered a situation where trying to define something led to contradictions or unexpected results? Feel free to share your experiences in the comments. If you enjoyed this exploration of quantum mechanics and the Cauchy-Specker theorem, don't forget to like, comment, and subscribe. We'll continue to dive deeper into the mysteries of the universe and our own understanding of reality. Field fluctuation. Have you ever wondered if the space around us is truly empty? If you were to look at a quiet room with no sound, no movement, and nothing around you but stillness, it might feel like absolute calm, right? But what if I told you that in this stillness there is something constantly moving, changing, and shifting? Something that even gives birth to particles out of nothing? It might sound strange, but it's a concept that challenges the very fabric of our understanding of the universe. Space in its emptiness isn't really empty at all. Instead, it's filled with fields that are constantly jiggling, fluctuating, and giving rise to particles, almost as if the universe has a mind of its own, making something out of nothing whenever it pleases. Imagine you're standing on the shore of a lake, watching the surface of the water. At first glance, the lake may seem perfectly calm, reflecting the sky above. But if you watch long enough, you start to notice small ripples forming here and there. These ripples are unpredictable. They appear out of nowhere and fade just as quickly. You can't predict exactly when they'll happen, but they're a natural part of the environment. In a way, space behaves like that lake. Even though we may not see it, the fabric of space itself is constantly in motion, creating small fluctuations or ripples that can give birth to particles. These tiny fleeting particles pop into existence for an instant and then vanish again, like bubbles appearing on the surface of the water. It's a strange thought to consider. Space, the very thing we think of as empty, is never truly still. It's always fluctuating, shifting, and moving in ways we can't easily see or understand. These fluctuations give rise to particles that appear out of nowhere, only to disappear again, like an illusion. It's as though the universe is playing a game with us, showing us these fleeting moments of creation and destruction. It's difficult to wrap our heads around, but it reminds us that our understanding of the world is always limited by what we can observe. Let's bring this idea into something more familiar. Think about the way a relationship can feel like it's constantly shifting. One moment, everything feels calm and steady, and the next, something small shifts and a new dynamic is created. You might not see the change coming, but you can feel it. Similarly, in the universe, the underlying fields that make up space are constantly shifting, giving birth to new particles, just as a change in a relationship can lead to new emotional experiences. These small changes are unpredictable and can sometimes feel like they came from nowhere, but they're part of a larger process, a constant ebb and flow. This concept also touches on the way we look at our own lives. Think about the times you've experienced sudden, unexpected changes, perhaps a new opportunity, a surprise challenge, or a new realization about yourself. These moments can feel like they appear out of nowhere, just as the particles in the field fluctuate into existence. It can feel unsettling, as if we have no control over these changes. But like the fluctuations in space, these moments are part of a larger, unpredictable flow that shapes our experience. Sometimes it's hard to accept that life isn't always calm and steady, but rather a series of shifts and changes that arise when we least expect them. This paradox of fluctuations in space is also mirrored in the world of technology and artificial intelligence. Much like the way space's fields create particles from seemingly nothing, AI systems are constantly processing data, adjusting, and evolving in real time. They don't remain fixed or static. Just as space's fluctuations create particles that we can't always predict, AI continues to change, adapt, and generate responses based on new information, making it a dynamic system that is always evolving. It's like having a conversation with someone who can never stop learning and adapting, always giving you something new to think about. The bigger theme here is about the unexpected. Life is full of surprises, just as space is full of fluctuations. It can feel unnerving, even chaotic at times, but it's a reminder that there's a certain beauty in the unpredictability of life. The same way a calm lake can hide ripples beneath its surface, the universe hides a constant motion that we can't always see. Our lives, too, are full of moments of unexpected change and growth. We may not always see these moments coming, but they help shape who we are and how we experience the world. This unpredictability makes life vibrant and full of potential. Now consider this. Have you ever felt like the world around you is moving too fast, or that changes seem to appear out of nowhere? How do you respond when unexpected shifts occur? It can be challenging but also freeing to embrace the idea that life is not meant to be completely predictable. Just like the fields of space give rise to particles without warning, our experiences are shaped by moments of change, some of which we can't predict or control. This paradox teaches us to accept the ebb and flow of life, the shifts that shape our journey, and the beauty in letting go of the need to control everything. Before we dive deeper into this, I'd love to hear your thoughts. Have you ever experienced sudden, unexpected changes in your life that felt like they came out of nowhere? How did you handle it? Feel free to share your experiences in the comments below. If you found this concept intriguing, don't forget to like, comment, and subscribe to stay connected. Let's continue to explore the mysteries of our universe together, one fluctuation at a time. 0 point C. Imagine the most silent and still place you can think of. An empty room, a vast desert, or perhaps the stillness of a frozen lake in the middle of winter. You might think that in these moments of perfect quiet, everything has come to rest, that there is nothing more to be said or done. But what if I told you that even in the stillest of moments, when everything appears frozen and motionless, there is still something happening beneath the surface? This is the strange reality of what scientists call zero-point energy, a phenomenon that suggests that even at the absolute coldest temperature, when everything should technically stop moving, the very fabric of the universe is still alive, with tiny, restless motions. These tiny movements are so small that we can't see them with our eyes, but they are there, shaping the world around us in ways we don't fully understand. It's like a hidden sea of energy that exists even when nothing else seems to be happening. Picture yourself standing at the edge of the ocean, watching the gentle waves lap against the shore. The ocean seems calm, the water appearing still. But when you look closely, you notice that the waves are never truly still. Even in moments when the water appears to be perfectly flat, there is always some movement beneath the surface, a constant shifting, a motion you can't quite see but can certainly feel. The same is true of the universe itself, even when it feels like everything is at rest. The idea of the 0 point C suggests that at the most extreme cold, at absolute zero, when all motion should cease, the quantum fields that make up everything around us are still in motion, tiny fluctuations like ripples on the ocean happening all the time. Think about those moments in your life when things seem perfectly calm and quiet, and yet you can feel a certain energy, an undercurrent of something more, something moving just beneath the surface. It might be a quiet day, but there's a sense of anticipation in the air, or a feeling that something big is just around the corner. It's as if the calm you feel is only the surface, while beneath, there's a world of unseen possibilities and changes, waiting to reveal themselves when the time is right. This feeling of hidden movement beneath the stillness mirrors the 0 point C in the quantum world. Even when everything seems still, there is still something quietly shifting, shaping what's to come. This paradox touches on something deeply human, the idea that nothing is ever truly still, even in moments of silence or stillness. Much like how we sometimes feel like we're standing still in life, waiting for something to happen. The 0 point C reminds us that change is always happening, even if we don't always see it. It's easy to get caught up in the feeling that nothing is changing in our lives when we're stuck in a routine or feeling uncertain about the future. But the truth is, much like the quantum fields, even in those moments when we feel frozen, things are still shifting. Perhaps it's our thoughts, our beliefs, or the tiny changes we make in our daily lives that, over time, will lead to something bigger. Just as the universe's fields are constantly in motion, we too are constantly evolving in ways we might not immediately notice. This can also be a powerful way to think about our mental and emotional well-being. When we go through tough times, it may feel like we are stuck in place, with no progress or change. It might feel like we're frozen in time. But much like the 0-point C, there is always subtle motion happening. Our emotions may shift in tiny ways that we don't notice at first, and just like the smallest ripples on the ocean, those changes can eventually create larger waves of transformation. Over time, these small shifts can help us heal, grow, and move forward, even when it feels like we're standing still. The idea of constant motion beneath the surface also connects to the world of technology. Think about how artificial intelligence and other systems are constantly evolving, even when we don't notice it. These systems are never truly idle. They're always learning, adjusting, and adapting. Just as the quantum fields are never at rest, AI systems are always processing data and evolving, sometimes in ways we might not immediately see or understand. The same way we can't always see the tiny fluctuations in the 0-point C, we may not always notice the subtle ways in which technology is changing and evolving. Yet, just like the ripples beneath the water's surface, these changes can have a profound impact on our world. At the heart of this paradox is the idea that even in the absence of obvious change, there is still something happening, a constant, invisible energy that is shaping our reality. In the same way, we might not always see the immediate impact of our actions, but that doesn't mean they are without effect. Small gestures, kind words, and subtle shifts in our mindset can create ripples that affect the world around us, even when we don't immediately see their results. Just as the quantum fields churn beneath the surface of the universe, our small, often unseen actions can have a profound influence on the world around us. Now, I'd love to hear your thoughts. Have you ever experienced a time in your life when you felt stuck, only to later realize that changes were happening beneath the surface all along? How do you deal with moments when it feels like nothing is moving forward? Feel free to share your experiences in the comments below. If you found this paradox interesting, don't forget to like, comment, and subscribe so we can continue exploring these mysterious and fascinating ideas together. Let's dive deeper into the unseen forces that shape our world and our lives, just as the quantum fields shape the universe. Super dense coding. Have you ever wished that you could send more with less? Like managing to get two things done with just one action? What if I told you that scientists have discovered a way to do something even more mind-blowing? Sending twice as much information by sending only one tiny particle? It sounds like science fiction, doesn't it? But this is the fascinating reality behind a concept called super-dense coding, a breakthrough in the quantum world that allows us to transfer 2 bits of information with just one particle. Let's take a moment to imagine how this could work, and what it might mean for our understanding of communication and connection. In our everyday lives, we are constantly exchanging information. We text our friends, chat on the phone, and send emails. When we do this, we send messages that are made up of bits, those small digital units of information. Each bit carries a tiny piece of data, like a yes or no, a 1 or a 0. Now, imagine being able to send not one but 2 pieces of information with a single action. It would be like having a conversation with someone, but instead of saying 2 sentences, you only need to say one that conveys the exact same meaning. Sounds impossible, right? But quantum physics has a way of making the impossible seem possible, and that's where superdense coding comes in. Superdense coding relies on a special feature of quantum mechanics called entanglement. Entanglement happens when 2 particles become linked in such a way that the state of one particle can instantly affect the state of the other, no matter how far apart they are. It's as if they are connected by a hidden thread, and no matter the distance, what happens to one particle will have an effect on the other. With this spooky connection between particles, we can achieve something remarkable. By sending just one particle, you can actually send 2 bits of information. Imagine this. You and a friend are standing on opposite sides of a vast room. Normally, if you wanted to send a message to your friend, you would have to speak to them or pass a note. Each word, each message would take time and effort to get across. But with entanglement, you can create a connection between you and your friend that doesn't require the usual channels of communication. It's like you and your friend are already connected in a way that makes sending information much faster and more efficient. By simply sending one particle, you can convey twice as much information as you would normally be able to. This might feel a little like magic, and in some ways, it is. But what's even more fascinating is the bigger picture it reveals. When we think about our lives, we often feel like we are limited by time, space, and the way we communicate. We can only do so much in a day, and the way we share ideas and connect with others is often slower and less efficient than we would like. Superdense coding reminds us that there is always more to explore beyond the surface, whether it's in the way we communicate or in the way we see the world around us. This paradox also invites us to rethink what we believe is possible. So often, we go through life assuming that things have to be done in a certain way, following a set of rules that we've come to accept as true. But quantum mechanics, with its strange and unexpected discoveries, shows us that the universe doesn't always operate according to the rules we expect. Just as superdense coding allows us to send more information with less effort, we might find that in our own lives there are ways to achieve greater results with less struggle. It might not always be easy to see at first, but sometimes the biggest breakthroughs come when we step outside the usual way of thinking. Take a moment to think about times when you've had to communicate something important. Maybe it was a conversation with a friend or family member, or perhaps it was a moment when you were trying to explain a complex idea at work or school. How often do we feel like we're running out of time or struggling to get our message across? We send text after text, email after email, trying to fit all our thoughts into a limited space. What if, just like in superdense coding, we could send twice as much with half the effort? The idea of sending more with less could have a powerful impact on how we communicate, not only in our personal lives but also in the wider world of technology, business, and even education. When we think about superdense coding, it's not just about sending information. It's about the potential to revolutionize how we share ideas, how we connect with one another, and how we solve problems. Imagine the possibilities if we could communicate more efficiently, if we could convey complex ideas with fewer words, or if we could instantly connect with people across vast distances with minimal effort. This could change the way we work, collaborate, and build relationships, both in our personal lives and in larger systems of communication. What's even more intriguing is how this principle might apply to technology and artificial intelligence. Just as quantum particles can share information more efficiently, AI systems are constantly learning and adapting in ways that we don't always see. The future of communication could be shaped by the principles of quantum mechanics, leading to systems that can process and share information much faster and more efficiently than we ever thought possible. As we continue to develop new technologies, who knows how the lessons of superdense coding might influence the ways we interact with machines and one another in the years to come? Before we dive deeper into the fascinating world of quantum mechanics and communication, I'd love to hear your thoughts. Have you ever experienced a time when a simple action or idea had a much greater impact than you expected? Do you think the way we communicate could be made more efficient? And if so, how? Feel free to share your thoughts in the comments below. And if you found this paradox intriguing, don't forget to like, comment, and subscribe to stay connected as we explore more of the mysteries that lie at the heart of the universe. Let's continue our journey into the unknown, where ideas like superdense coding reveal the hidden possibilities all around us.